Hello everyone, and welcome to this Unreal Online Learning course where we're going to build a third-person character from scratch. We're going to build a third-person character setup using assets from the Stackerbot project. The Stackerbot project is available from the Unreal Marketplace. My name is Stuart Butler and I'll be your instructor for this course. I have over 12 years of games teaching experience and I'm the course director for Games Technology at Staffordshire University in the UK. I've been working on games for over 15 years on projects ranging from mods to console and mobile titles. I'm an authorised Unreal instructor and have a broad interest across games development in design, art, animation, and importantly, Unreal Engine. In this course, we're going to be building a playable character using existing art assets from the Stackerbot project. We'll be utilising the enhanced input system to control the character, working with animation blueprints to bring the character to life, implementing different third-person camera setups, and expanding the character movement with dynamic jumps and a jetpack. Let's take a look at what we will be building. The third-person character that we'll be creating in this course has the ability to run around the map, jump, and use a jetpack. Our camera setups include a full 360-degree camera that has limited vertical movement, as well as an over-the-shoulder camera, which has the ability to swap between shoulders. Now you've had a glimpse at where we're heading, let's get started by creating and linking the key assets in the next video. To get started, we're going to create the required assets for our third-person character. We're going to create character and animation blueprints. We'll then select the character mesh and animation blueprint in the character and add idle animations from the Stackerbot assets. I've gone ahead and created a new level in the Stackerbot project. You can do this by going to File, New Level, and selecting the template default from the pop-up. The first thing we're going to do is create the template
default. What is that? I don't have that. I wonder. Maybe. Options. No, starter content's there. Whoops, I didn't mean to close the entire app. Oh, didn't close, good. Template default. Alright, we're off to a great start. Something's already missing. Alright, so found someone else saying they had the same issue, and the basic should be sufficient. We're going to go with that.
The first thing we're going to do is create a new folder to hold all of the things we're going to create in this course. To do this, we need to open our content browser by clicking the content drawer button in the bottom left corner of the screen. Because we're going to be creating quite a lot of assets, I'm going to dock this by clicking the Dock Layout button. Now I'm going to right click and select New Folder. I'm going to call the new folder Third Person Character Course. Next, I'm going to create a blueprint folder. Inside, I'm going to create our character blueprint and our animation blueprint. First up, I'm going to right click and go to Blueprint Class. From the pop-up, I'm going to select Character. I'm going to call this BP_StackBot. Next, I'm going to right click again and go to Animation, Animation Blueprint, and select the SKBot skeleton. This is the skeleton of the character mesh that we're going to use. I'm going to click Create and call this ABP_StackBot. So I'm going to open up BP_StackBot, and I'm going to drag the tab and put it in the top of my normal viewport. This just means I can swap between the map and our content browser, and then the blueprint that we're working on. In the top left corner, I'm going to select...
Ooh, is that already... Oh, no. Okay, we gotta fix that immediately. Wait, so... That. 'Cause screw you.
the mesh component. I'm going to come down to skeletal mesh and set this to. In the top left corner, I'm going to select the mesh component. I'm going to come down to skeletal mesh and set this to be skm_bot. In the viewport, we should now see that our character has appeared. At this point, I'm also going to select the anim class, which if we drop this down is the abp_stackbot that we just created. I'm going to lower the character down and turn him through 90 degrees so he's facing the same direction as our directional arrow.
60, 90.
You'll notice that the capsule is too big. This will result in the character floating and also hitting things as he walks under them. We're going to change the capsule half height to 60.
Where are you? I know I can search for it, but I want to see. Oh! Helps to be on the right thing. God, actually, wait. Who did they...
So he's facing the same direction.
Okay, they did
as our
rotate the
directional
motion,
arrow. You'll notice that the capsule is too big. This will result in the character floating and also hitting things as he walks under them. We're going to change the capsule half height to 60. This now means the capsule is at the bottom of his feet and below the top of his head. Going to compile and save, and then move across back to the map and select the animation blueprint. In the animation blueprint, I'm just going to drag in a_bot_idle and plug this in to the output. When we compile, we should see the character snap into an idle animation. We go back to the blueprint to confirm that we selected the right animation blueprint.
Huh. Neat.
We can see him now playing the idle animation. In the next video, we're going to add a basic camera setup and place the character in the world. Now we have our basic components set up, making use of some of the available assets. We can now move on to giving the player the ability to see the character. In this video, we're going to add a camera and place the character in the world. We're going to add components to the character for the camera. These are a spring arm component and a camera component. The spring arm holds the camera and allows us to set the distance the camera is away from the character, rotate the character around a fixed point, as well as handling collisions with geometry to avoid clipping. We'll be placing the character in the world and setting up auto possession so we can preview our camera placement and make adjustments to get the right feel for the third-person view. Now we're going to add our camera components to the character blueprint. So I'm going to open up the character blueprint, and in the left-hand side, I'm going to click the Add button. I'm going to scroll down and select the spring arm. With the spring arm selected, I'm going to click Add again and select Camera. Keeping the spring arm selected whilst adding the camera will automatically set the camera as a child component of the spring arm. It will also place the camera at the end of the spring arm. We should also set the parent socket to spring endpoint.
socket, got it. Spring endpoint, look at that.
With that done, we can compile and save, and then drop the character into the viewport. Once the character is in the viewport, we should get a preview which will show us what the camera is going to look like in game. This is a bit low, so we need to move it up. I'm going to swap over to the blueprint, select the spring arm, and then move the spring arm up 50 units. When we compile and go back to our level, we should now see that we've got a much higher camera. I'd like to see a little bit more of the floor behind the character, so I'm going to go back once again, select the...
Oh, I never even saved the... Oh yeah, technically they haven't even saved either, it's still untitled. That's right.
spring arm and change the target length to 350 units.
Spring arm. Target number 0350.
Just going to check what that looks like. And this is now looking a lot better. To be sure about what our camera view is going to look like, we need to check it in-game by possessing the character. To do this, we need to delete the player start, select the character, and in the search...
Delete the player start. Select the character.
Search box, type possess. We want to swap auto possess player from disabled to player 0. To test the character, we want to play the game in a new window. This will ensure the correct aspect ratio when we're previewing. So click the 3 dots and select New Editor Window. We can now see our character in the centre of the screen, well placed with a good amount of the world behind the character and a good view of what's in front. Now the camera is positioned and possession is set up, we can move on to setting up our controls. In the next video, we're going to use the enhanced input system to control our character and move it around the world.
What did I just do? Oh, I clicked into... Okay, I see. Interesting. There it goes.
In the next video, the camera is positioned and possession is set and a good view of what's in front. Now the camera is positioned and possession is set up, we can move on to setting up our controls. In the next video, we're going to use the enhanced input system to control our character and move it around the world. Now we have our basic assets sorted, we're going to set up the control system to allow the player to control the character. We're going to make use of Unreal Engine 5's new enhanced input system. Unreal Engine 5's enhanced input system uses input action assets and an input mapping context to configure our controls. The actions, once created, are set up inside the mapping context with addition of input modifiers to handle inversion of inputs when using W8 S&D, as well as dead zones for analog thumbsticks on gamepad controllers. The mapping context is then added as part of the character blueprint to enable the use of the enhanced input action events. To start with, create a new folder called Input. Inside, right-click and go to Input, Input Action. I'm going to name this IA_move forward CC. The IA stands for Input Action, Move Forward is the action that we're going to do, and CC for Character Course, just to keep these input actions separate from the input actions already in the Stackerbot project. I'm going to open up the input action and change the value type from digital ball to axis 1D float. This will change the input's behavior from being an on-off button to being a -1 to +1 float variable. I'm going to save and close that down. I'm now going to duplicate the input action twice by pressing Ctrl and D. The first one will be IA_move right CC, and the second one will be IA underscore turn CC. These input actions will be used for moving left and right and turning. The next thing we need to create is an input mapping context. I'm going to right click and go to input and select input mapping context. I'm going to call this IM for input mapping underscore third person CC and save it. Now we need to add the input actions to the input mapping context. We need to add the input actions to the mapping list. To do this, click the plus next to mappings and from the drop-down select the input actions we just created. Putting CC in the search box should filter the list to show the input actions we just created. I'm going to start with IA underscore move forward CC. Now we need to add the buttons that we'd like to use for this input action. By clicking the icon, we can then press the button on the keyboard and it will automatically select the chosen control. With W added for forwards, we're now going to add S for backwards. Because S is the negative of forwards, we need to go to the modifiers and add a modifier. With W added for forwards, we're now going to add S for backwards. Because S is the negative of forwards, we need to go to the modifiers and add a modifier. From the drop-down, select negate, and this will change the input to -1 instead of +1. The last control I'm going to add is the gamepad left thumbstick y-axis. So I'm going to add a control binding, and from the drop-down, select gamepad, and then I want left thumbstick y-axis. For any thumbstick, we need to add a dead zone. So I'm going to add a modifier, and from the drop-down, select dead zone. I'm going to expand this out and change the type from radial to axial. This is because the thumbstick is only working on one axis, so we only need the dead zone for a single axis. The input actions and control bindings are shown here. Feel free to so we only need the dead zone for a single axis. The input actions
Oh. You sound like a bot to me. You're griffin food, right? Griffin food? Pretty sure you're griffin food. Bots aren't the best griffin food, but bots are griffin food.
and control binding
So move right. D A negate gamepad. X axial. Where did they just have the axial? Dead zone. Type axial. There you are. Char forward CC, which do a churn. Mouse X. Mouse X. Game. Pad right thumbstick. X. Plus dead zone. Plus axial. Aha!
Are shown here. Feel free to pause this video whilst you set those up. When you're ready, continue watching and we'll create the blueprint logic for each of these input events.
Goodbye, Griffin Food.
With the control binding set up, now we can go over to the character blueprint and set up our logic. In the character blueprint, we're going to navigate to the event graph and below the existing nodes. We're going to right click and type event possessed. From this, we're going to drag out of new controller and cast to player controller. From here, we're going to search for enhanced and choose get enhanced input local player subsystem. Then going to drag out of here and search for add mapping context. This node allows us to add our mapping context to the player controller. From the mapping context dropdown, we're going to select mapping context and search for local player. From here, we're going to search for enhanced and choose get enhanced input local player subsystem. Enhanced player controller. From this, we're going to drag out of new controller and cast to player controller. From here, we're going to search for enhanced and choose get enhanced input local player subsystem. Then going to drag out of here and search for add mapping context. This node allows us to add our mapping context to the player controller. From the mapping context dropdown, we're going to select IAM_third person CC. Next, we're going to create this dropdown. We're going to select IAM_third person CC. Next, we're going to create the logic for our input actions for movement. We're going to right click and look for move forward CC. The input action event for move forward is going to call an add movement input node. The add movement input node requires a world direction and a scale value. For the scale value, we're going to use our control value. And for world direction, we're going to make use of the control rotation of the character. The node requires a movement input node. The add movement input node requires a world direction and a scale value. For the scale value, we're going to use our control value. And for world direction, we're going to make use of the control rotation of the character. So I'm going to right click and type get control rotation. From this, we're going to break the rotator. And this is because we only want to use the yaw parameter. I'm going to drag out of yaw and type make rotator. Now this will connect the yaw to the roll. So we're going to disconnect that by holding Alt and clicking, and then reconnect the yaw input.
Make rotator.
From here, we're going to drag out, and we want get forward vector. Our forward vector is then going to be connected to the world direction of our add movement vector. From here, and then this will connect. We're going to drag out of yaw and type make rotator.
I think the context thing is what got me.
Now this will connect the yaw to the roll. So we're going to disconnect that by holding Alt and clicking, and then reconnect the yaw input. From here, we're going to drag out your input.
Make rotator, break rotator. Oh, wait. Okay. Different rotator.
From here, we're going to drag out, and we want get forward vector. Our forward vector is then going to be connected to the world direction of our add movement input node. I'm then going to create the move right CC event node. I'm going to duplicate the add movement input. I'm then going to create the move right CC event node. I'm going to duplicate the add movement input with Control D and connect it to the triggered pin. I'm then going to drag out of our make rotator and get right vector. This is going to be the world direction for our move right, and we're going to connect the scale value to our control action value. The last event we need to create is for our turning. So I'm going to right click and type turn CC and select IA underscore turn CC. And from here, I'm going to drag out and type add controller U turn CC is for our turn control action value. The last event we need to create is for our turning. So I'm going to right click and type turn CC and select IA underscore turn CC. And from here, I'm going to drag out and type add controller your input. I'm going to connect the val to the action value. And now we should be done. So I'm going to compile and save and go back to our map. I'm going to press play. And now when I press any of the input back to our map, I'm going to press play. So I'm going to compile.
Yeah. All right then. Neat.
And save and go back to our map. I'm going to press play. And now when I press any of the inputs, the character will move around. Moving the mouse will spin the character, and we can do these all at the same time. With the controls set up, we can now move our character around. At this point, it's purely functional, but we will be adding the visual aspects such as animations a little later on in the course. Next up, we're going to return to our camera and look at some options for alternative third-person cameras and how to implement them.
Okay. So favor lines over nodes is at least this recommendation. I don't know how to get this to be... Oh, there we go. I don't know if I can get that any better. I think that's okay-ish. Yeah, it's not happy. I don't know why it does that. Okay.
Third-person games can use different cameras to provide their signature feel to gameplay. In this video, we're going to explore a more action-styled, over-the-shoulder camera, similar to what you might find in Gears of War or Fortnite. We're going to set up two locations for our camera, one looking over each shoulder, and give the player the ability to swap between them. We're going to start by renaming the existing camera and spring arm components we created earlier. This will make things easier to manage later on, and is generally good housekeeping. For this camera setup, we're going to create a new camera and spring arm, and set the auto activation settings on each camera. To enable shoulder switching, we'll be creating a new input action, which will trigger a timeline which will move the camera. We're also going to add some variables to enable tweaking of the camera positions later, and use the construction script to ensure the correct camera positions at all times. The first thing we're going to do is rename our original camera. So in the character blueprint, in the components list, I'm going to rename these and place follow in front of each of their names. So we'll have the follow spring arm and the follow camera. This will help us differentiate them from the new camera and spring arm we're going to create now. So now we're going to select the capsule, click add, and add a new spring arm and camera as we did the first time round. The camera is parented to the spring arm, and we're going to set the parent socket to spring endpoint. I'm going to rename both of these shoulder, so that we have a shoulder spring arm and a shoulder camera. So that our character uses the shoulder camera, we need to go to the follow camera and turn off auto activate. We can now go into the viewport and off auto activate.
Auto active. Okay.
We can now go into the viewport and move our shoulder spring arm to where we want our shoulder camera to be. We're going to move it up to the same height as the follow camera, and then we're going to move it across. I actually want this at minus 45 units. So I'm going to change my grid snap settings to 5 and move it across 45 units.
I can also just type it in, but yes. Negative 4550. Okay.
I'm going to change this back to 10 because generally 10 is fine. I'm going to compile and save. In the input folder, I'm going to create a new input action and call this IA_show switch CC, the shoulder switch. I'm going to open this up, and this time I'm going to leave this as a digital ball.
Oh,
Let's save it and close it back down. Now in the input map, I'm going to save it. I'm going to open this up, and this time I'm going to leave this as a digital ball. I'm going to save it and close it back down.
That didn't change it.
Now in the input mapping context, I'm going to add our mapping, search for our newly created show switch CC, and set the controls. I'm going to set these to Q and gamepad left thumbstick button.
Stop expanding.
I'm also going to add
things
triggers to both the controls. So under the triggers, I'm going to add an element, select the and gamepad. I'm going to set these to Q and gamepad left thumbstick button. I'm also going to add triggers to both.
Okay, that's super annoying. Alright, well, Unreal, you can't be great at everything. Is it going to expand like every single thing too? We'll find out in a minute. Oh, now you're not expanding stuff. I see how it is. Gamepad left thumbstick button. Gamepad left thumbstick button.
Pad left thumbstick button. I'm also going to add triggers to both the controls. So under the triggers, I'm going to add an element, select the drop down, and choose pressed. And do the same here. So that these are both set to have triggers of pressed. This will mean if we hold the button down, it will still only trigger once. This stops the camera from constantly flickering and never actually changing sides. So I'm going to save that and close it down and go back into our character blueprint. In the event graph, under the other inputs, I'm going to right click and type IA_SHO, and we should get our shoulder switch CC input action. For the shoulder switch, we're going to use a timeline to move the camera. So from triggered, we're going to drag out and create a timeline. The timeline we're going to call T_show switch. I'm going to open up the timeline and set the length to 1 second. I choose to add a float track and name this cam location blend alpha. For the curve, I want a curve that goes from 0 to 1 with at 0, 0 and then 1, 1. And I want a gentle acceleration into the movement and then a gentle deceleration when it comes to a stop. This will just make the camera transition nice and smooth. So I'm going to right click and add 2 keys to our curve. For the first key, I'm going to set this to 0 and 0. And for the second key, I'm going to set both values to 1. So time 1, value 1. I'm going to right click and then set auto as my tangents on both keys. This will then give us that gentle acceleration and gentle deceleration as our camera moves. So I can now close this and note that the timeline now has a camlock blend alpha pin. The timeline is going to set the relative location of our shoulder spring arm. So I'm going to drag the shoulder spring arm in, drag out, and type set relative
shoulder spring arm.
Location. I'm going to plug this into the update I'm going to drag out of new location and type lerp. This will give us a linear interpolation between the two vectors a and b based on the alpha. The alpha is going to be driven by our curve, and then for a and b we're going to set our camera locations. So for location a we're going to use the start location. The alpha is going to be driven by our curve, and then for a and b we're going to set our camera locations. So for location a we're going to use the start location of the camera, which is -45 on the y and 50 on the z. For location B, we're going to use +45, which will be over the other shoulder, and 50 again for the Z. With that set up, we should now be able to go and test it. So I'm going to compile and save and go back to our map. I'm going to press play. And now when I press Q, the camera will swap sides. At the moment, the camera will only swap sides once, so we need to go and change that. Back in the camera, so I'm going to compile and save and go back to our map. I'm going to press play.
Mine's still center. What did I miss? What did I miss? What did I miss? Follow spring arm. Wasn't there auto activate?
I'm going to compile and save and go back to our map. I'm going to press play.
Why? Was that supposed to be not auto-activate on the camera? I don't know, I'll do it on both of them. Let's see what happens. Okay. So
Now when I press
we're
Q,
about 6 minutes in. Where did they do that?
element and close.
Dagane, how you doing? Hope you're well.
Compile and save.
Where did they disable the active? I think it was right about here.
Activate camera. We need to go to the follow camera and turn off auto activate.
Okay. So they did it only on the camera. I did it on the spring arm. That's what I made the mistake. So this can be auto activate even though there was a. Okay. Good, using channel points to unlock your sub modes. Yeah. I'll get something to use points on eventually. Mur has over 1 million. Yeah. Tail. Big, thick, meaty tail. Alright, we were at 6 minutes. I need to go back to that.
Back to our map.
Oh yes. It's a happy burb. Such a happy burb. Loop. Chirp, chirp, chirp.
The camera. I'm going to press play.
This is a burb. This is lubricant.
And now when I press Q, the camera will swap sides. At the moment, the camera will only swap sides once, so we need to go and change that. Back in the character blueprint, we need to add a node between our control and our timeline. Move these out the way slightly. And what I'm going to add is a flip-flop node. A flip-flop node.
Dude, how'd you do that?
Flip-flop node.
Oh, you just dragged. Okay, interesting. Flip-flop. Okay.
A flip-flop node swaps between exiting in pin A or pin B every time it is pressed. So the first time it will go through A, the second time B, and then keep flipping and flopping. We now need to plug B into reverse.
Yeah, that was
Note
great.
that we've used play and reverse and not play from start and reverse from end. This will prevent the camera from jumping if we press the control a second time. Let's go and give that a test. We press play. When I press Q, we'll swap to the right shoulder, press Q again, and we come back to the left shoulder. To give ourselves the maximum control later, I'm going to promote both of the vectors from the lerp to be variables. So I'm going to right-click pin A and choose Promote to Variable. I'm going to call this L Show Cam Lock, the left shoulder camera location. I'm then going to repeat this for B and set that to R Show Cam Location. And tidy this up so they're not on top of each other. And then press Compile. You can now see that we can set both of these values by variables rather than coming to find the node that's affecting them. We do have to make one more change to our setup, because right now if we were to change these variables,
No, don't drag. I want to move. No, 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 no. There you go. Yeah, that seems to work okay. Lurk, thank you for the lurk. I hope you have a great rest of your day.
these values by variables rather than coming to find the node that's affecting them. We do have to make one more change to our setup, because right now if we were to change these variables, the camera would still start in the position that's set in the swing arm. So we need to go to the construction script, bring the spring arm in, drag out and type set relative location, because we're going to set the relative location when the character is created. For the location, we're going to use the left shoulder camera location, and we should be good to go. So if we were to change both of these variables now, the camera will start in the right place and move to the correct place when we press Q.
Set.
Both our cameras so far are fixed in place behind the correct place. Change the camera location. For the location, we're going to use the left shoulder camera location.
Oh, literally, it just automatically does a thing. Okay.
And we should be good.
Construction script. Oh, helps to run the bloody thing, huh? I see, okay.
Go. So if we were to change both of these variables now, the camera will start in the right place and move to the correct place when we press Q.
Neat.
Both our cameras so far are fixed in place behind the character. This isn't always the case in third-person games, so in the next video, we're going to take a look at allowing the player to freely rotate the original follow camera around the character. Another way that a camera can change the feel of gameplay is to give the player the ability to rotate the camera around the character, allowing them to look around as they move the character around the environment. This sort of setup is common in more adventure-focused character setups, such as those featured in the Assassin's Creed games. To set up the 3D rotating camera, we need to modify how the character blueprint responds to the player controller, and set up a new input action to allow the player to look up and down. We'll also limit how far the player can rotate the camera up and down by modifying the minimum and maximum pitch variables of the player camera manager. So the first step is to swap our cameras over, so we go back to using the follow camera as opposed to the shoulder camera. To do this, we're going to go into the character blueprint, select the follow camera, and turn auto activate back on. Then in the shoulder camera, we're going to turn it off. Then compile and go back and just test this and make sure the character is standing in the middle of the screen. Now we can go into the character blueprint and change some of the behaviors about how the character responds to input and rotation. In BP_stackpot cell, we're going to search for rot. We're going to turn off use control rotation.
Instruction. Oh, BP set match. Yeah.
Rotation yaw. Then we're going to swap over to the character movement component with the same search. We're going to turn on orient rotation to movement. This will mean the character will automatically rotate to face the direction of movement. So that rotation is a bit snappier. We're going to change the rotation rate from 360 to 700. We're also going to go to the follow spring arm and turn on use pawn control rotation. With that done, we can compile and save and go back and test. We should now be able to rotate the camera freely around the bot. When we give it input, the bot should automatically rotate in the direction of movement.
Oh, that's cool.
We should be able to turn the character still by holding W and moving the mouse, and it will run in the direction we are looking. We can't at this point look up or down, so that's what we're going to add next. In the input folder, we need to add a new input action. We're going to call this IA. So that's what we're going to add next. In the input folder, we need to add a new input action. We're going to call this IA underscore lookup CC. This needs to be an axis 1D value type, and then we can save and close. In the input mapping context, we now need to add our new mapping. I'm going to add it to the list.
Interesting. I think I'm understanding what your, in my opinion, bug is.
Select it and set our controls. Lookup is going to be based on our mouse, Y. We're also going to add gamepad, right thumbstick, Y. We need to add a modifier of a dead zone because it's an analog stick, and change the type to axial. We're going to save this and close it. To set up the controls for looking up, we need to go back to our event graph, right click, and search for lookup CC. I'm actually going to place this next to my turn CC control. I'm going to drag out and type add control.
Sure, okay.
Controller pitch.
Add controller pitch. Probably this.
And connect the value to the action value. We should now be able to test this and see that we can look up and down. We have a slight issue that we can look very low and also directly over the top of the character. This isn't quite what we're looking for third-person gameplay. We can limit this using the player camera manager, but that's part of the player controller, so we need to create a new player controller and a new game mode to use it. So in the blueprint folder, I'm going to right click blueprint class and create a new game mode base. I'm going to call this G blueprint class. So in the blueprint folder, I'm going to right click blueprint class and create a new game mode base. I'm going to call this GM for game mode _ stackbot. I'm also going to right click the blueprint class and create a player controller. This is going to be PC _ stackbot. I'm going to open up the game mode and I'm going to set the defaults for our player controller class and our default pawn. Both of these being those that we've created in the course and our default pawn. Set the defaults, both of these being those that we've created.
Default pawn, BP, stackbot. Okay.
In the course. I'm going to close that down and go into the player controller. In the event graph, we're going to find event begin play.
PC stackbot.
And we're going to create some nodes here. I'm going to right click and type get player camera manager. I want the variables player controller, get player camera manager, not the game one. So I'm going to drop that in. Controller, get player camera manager. Not the game one. So I'm going to drop that in and I'm going to drag out. I'm going to search for view pitch. And I want set view pitch min. And I also want set view pitch max. I'm going to drop these in and add some reroute nodes just to tidy up how easy this is to read. The minimum value we're going to set to -65. The maximum value we're going to leave as 0. I'm going to compile and save.
-65, 0.
And close that down. Before we can test this, we need to override our game mode. So I'm going to click this button here and go to game mode not overridden. Select our game mode base class and then choose GM _ stackbot. Now when I press play, I should only be able to look so far up and shouldn't be able to look down at all. If you want to add a little bit of ability to bring the camera down, we can go back into the player controller and just set this view pitch max to 10. This will give us just enough so that we can have that little bit of ability to look up, but without going too close to the floor or ending up underneath the character. We can now control our camera. There are a lot of variables we can change in the setup to provide subtly different experiences. Try exploring different ideas by changing the length of the spring arm, angle of the camera, pitch maximum and minimum, and any other settings you can find. A camera can make a huge difference to the feel of a third-person game, so in making your own games, be sure to spend plenty of time exploring these settings. For the remaining videos in this course, we're going to continue using the freely rotating camera we've just implemented. If you want to swap back to the over-the-shoulder camera, simply swap the auto-activation balls on each of the cameras. In the next video, we're going to start looking into the animation systems to bring the character to life.
A lot of this is kind of review from the other tutorial that covered a lot of this, but it's good to go over it again.
Character's first blend space. Blend spaces allow us to blend animations in real time based on 1 or 2 parameters, depending on our requirements. A normal blend space uses 2 parameters to drive a 2-dimensional graph, whereas a blend space 1D only uses 1. We're going to set up a 1-dimensional blend space to begin with to get our character moving. To create our blend space, I'm first going to create a new folder. I'm going to call this one Animation, and inside I'm going to right click and go to Animation, Blend Space 1D. I'm going to select the bot and call this BS1D_ idle bot and go to Animation, Blend Space.
Wow, legacy. Blend space 1D. Interesting. Let's do this.
1D. I'm going to select the bot and call this BS1D_ idle run. I'm going to open it up. And then in the horizontal axis settings, I'm going to set the name
run
to speed 1D_ idle run.
Yeah.
I'm going to open it up. And then in the horizontal axis settings, I'm going to open it up. And then in the horizontal axis settings, I'm going to set the name to speed .
Just trying to see if there's a way to... How do you disable the vertical axis? I don't know.
The minimum axis value to 0 and the maximum axis value to 500. This is the maximum speed we're going to set the character to be able to walk later on. You can set the grid divisions to 1 because we only have 2 animations that we're going to use at this point, one for idle and one for running. First, we're going to drag the idle animation in. So from the asset browser on the right hand side, we're going to grab a_bot_idle and drag it to speed equals 0. You should see the character pop into an idle animation in the viewport. For 500, we're going to use a_bot_run and just drop that in place. Now when I hold Control and drag my mouse along the graph, you'll see the character begin to run. This is our preview point and it's quite handy to check that we've set up our animations. The character begin to run. Now when I hold Control and drag my mouse along the graph.
Ah, okay. So in the other video, they did that, but they didn't say how. They just exampled like, oh, now we can see that they go from 1 to 10, but they didn't say you had to hold down Control. So thank you for that. Interesting. Okay. So I still don't know how to get rid of the vertical axis, but it's like just not have a name. No, it's just okay. Good divisions. Snap wrap smoothing time. I don't know. So apparently the 1D is deprecated. So, I don't know. Oh, wait a second. No. Oh, okay, those are the samples. I don't know.
You'll see the character begin to run. This is our preview point, and it's quite handy to check that we've set up our animations correctly. Now we have the first blend space created, we can use it instead of the idle animation in the animation blueprint. In the next video, we're going to use our run blend space to get the character moving. In this video, we're going to create the first parts of our animation.
I really like these bite-sized videos instead of like, you know, a 3-hour, 1-hour video. It's just like little bite-sized snippets. I much prefer this. But
Blueprint. Animation blueprints use two different types of graphs. Event graphs, just like a character blueprint, and animation graphs, which use blueprint nodes to determine which animation should be played on the skeletal mesh during gameplay. Animation blueprints can easily become very complex. We're going to start simple by making use of a blend space we just created to make the character run when we move it around the world. As you progress through the course, we will expand this and make the system more complex. To add our new blend space into the animation blueprint, we need to open it up. Delete the A underscore. We need to open it up. To add our new blend space into the animation blueprint, we need to open it up. To add our new blend space into the animation blueprint, we need to open it up. Delete the A underscore bot underscore idle node and replace it with our BS1D underscore idle run. Going to connect the animation pose pin to the result pin, and then right click the speed variable input and select promote to variable. I'm going to rename this ground speed and press enter. So this is now given us a float variable which will drive our blend space. So I'm going to press compile and save, and then move over to the event graph. In the event graph, we're going to get the speed of our character as it moves around the world and use the event graph. In the event graph, we're going to get the speed of our character as it moves around the world and use that to drive the animation. So from try get pawn owner, we're going to drag out and search for a node called isValid. There's two options. We want the one with a question mark, which has an exec pin, which we can plug into our logic chain. Then going to drag out of try get pawn owner again and search for the movement component. We're going to get the movement component and then drag out and type get velocity. We only want the 2D velocity for the X and Y. We don't want to consider the velocity of vertical movement. So to do that, we're going to drag out of velocity and type break and choose break vector. And I want to make a vector again. I'm going to drag out of X and type make vector. I'm going to connect in the Y. And then from the return value, we want to get the vector length. The vector length is what's going to set our ground speed. So we can drag ground speed in, choose set, and then plug that together. I'm going to drag this into the isValid node and compile and save. Before we test anything, I'm just going to go over to the character blueprint and change the maximum walk speed to match our blend space. I'm going to go to the character movement component speed to match our blend.
Where did you see that?
Space. I'm going to go to the character movement walk speed to. Before we test anything, I'm just going to go over to the character blueprint and change the maximum walk speed to match our blend space.
Where?
I'm going to go to the character movement component and in the search box type max walk. Where we have 600 centimeters per second, we're going to change this to 500. We then compile and save.
Max walk. 5. Got it. Oh, interesting.
And we can give this a little test. Now when we run around the world, we should have our animation playing. Now that we've established a link between the character blueprint and the animation blueprint, we can start to expand the animation system to respond to a variety of variables and situations, providing an improved player experience and player character. In the next video, we're going to expand upon this animation system by looking at state machines. experience and to respond to a variety of different variables and situations, providing an improved player experience and player character. In the next video, we're going to expand upon this animation system by looking at state machines.
Alright. So... Oh, wait, this is... Oh, that's ya. Wait. Yeah. I'm being a derp. Gate. What are you? It's a float. Yeah. A gate float. Why do you have an exit? You should need that, I would think. Just trying to do the value. Mouse down. Mouse up. So push the mouse up and I look down. Oh, wait, I didn't think I compiled last time. This is me going off script. Okay. Pull the mouse down. I look down. Pull the mouse down and I look up. Push the mouse up and I look down. Okay. And right off the cliff. Also, where'd the sound go? I just realized the sound's no longer playing. Interesting. Okay. Oh. What if that... No. This... So, I know I could do it this way, but I feel like there's gotta be some... No, not that. This goes there. I feel like there's probably a cleaner way to do this. There we go. Pull down, down, up, down, up. Down, up, down, up, down, up. Neat. Now this little thing here, I'm very curious. Let's see. I wonder. What was that thing called? Is it target? No. Right, what do they call? What do they call? It's not parameter, is it? No. Set a component to zero shell. Not promote to variable. What did they call it? It was reroute node? I don't think it was that. No, that's what those are. What were they called? What were they called? Terminator show. Custom. No. Filament? No. No. Text element interface. No. Widget? No. No, it's definitely not that. Oh, what were those bloody things called? Alright, I give up. That would have been in the other... This one.
When it's pressed, is fired with the movement.
Was it this one?
And we want to move spawning orbs. So I
wonder if it'd be faster for me just to load the other. So I think it was actually named. Find it. I will. I need to remember what it was. Okay. Framework BP bot probably. I think it was under here. No. Component. No. It's not that. I wonder if I'm thinking of maybe it was a material thing. Add movement. That's just a boolean now. Branch event tick. No, that's not that. Okay. No, wait. That. No, wait, that's custom fence. That's not it. No, that's not right. I remember what they were called to look it up. Was it the other? Maybe it was done in the other. Trying to show BB and show. Game elements, framework, environment. Grass, flat rock. No. Let's get this. This was it. This was it. Okay. What are these called? And so this is a material thing. So maybe it's not possible. What were these called? Material expression? Output to no. What are you? Reroute. Reroute. Add reroute node. That. Reroute node. Named reroute node. Okay, it was reroute, and it's for materials. So it might not be available. I don't want to save. Reroute. Do we have that option? Add reroute node. It's just those. That's not what we want. Yeah, okay. Okay, so not. Okay, so how would you do this? If it's false, we want this value. If it's true, we want that value. I could create and set a variable, but I feel like there's some other way. I don't know. Maybe this is the way you would do it, short of creating and setting a variable. It's one of those I'll learn over time. This is not straight. I wonder if I can line that up with that now. That's good enough. I wonder, is there an order? Ah, there you go. Okay. No. Okay. Done. Moving on. Not you. You were... Yeah, we're not doing you right now. We are doing you. There we go.
In this video, we're going to develop the animation system using a state machine, and also implement leaning animations as part of a 2D blend space to replace our original blend space 1D. Our original blend space was a blend space 1D, which only allows us to blend animations based on one variable. The Stackerbot project includes some leaning run animations, where the character leans in the direction he is turning whilst running. Using these animations helps the character feel more realistic and balanced. We're also going to build our first state machine. State machines provide a graphical approach to selecting which animations should be played using a series of states, transition rules, and blend settings. So let's go into our animation folder, right-click, and create a new animation blend space. We're going to select the skbot, and we're going to call this bs_walk run lead. I'm going to open it up, and the first things we're going to do is set our axis settings. For the vertical axis, we're going to replicate what we had in our 1D blend space. So we're going to call it speed, set our minimum axis value to 0, and our maximum axis value to 500. We're also going to set the subdivisions to 1. I'm going to turn on snap to grid this time, so that when we place our animations, they snap into the variables. For the horizontal axis, we're going to call this lean. Our minimum axis value will be -1, our maximum will be 1, and our grid divisions will be 4. I'm also going to turn on snap to grid again, so that it makes life a little bit easier. Now we're going to bring in the animations. At 0, 0, we're going to bring in a_bot_walk. At 0 speed, at 0 lean and 500 speed, we're going to bring in a_bot_. At 0 lean and 500 speed, we're going to bring in a_bot_run. At -1 lean and 500 speed, we're going to bring in lean right.
Wait.
And at 1 lean and 500 speed, we're going to bring in and 500 speed, we're going to bring in lean right. At -1 lean and 500 speed, we're going to bring in lean speed. We're going to bring in at 0 speed, at 0 lean and 500 speed, we're going to bring in a_bot_run.
Okay, I see what
At
you're doing.
-1 lean and 500 speed, we're going to bring in lean right. And at 1 lean and 500 speed, we're going to bring in lean left. Now if I hold Control and move our preview value, you can see we have our run animation. As we move across the other axes, the character begins to lean. If we slow the run down, it slowly fades out the lean to have no lean at all when we're back in the middle. Go this way, hold Control and move our preview value. You can see we have our run animation. As we move across the other axes, the character begins to lean. If we slow the run down, it slowly fades out the lean to have no lean at all when we're back in the middle. Go this way, Control and move our preview value. You can see we have our run animation. As we move across the other axes, the character begins to lean. If we slow the run down, it slowly fades out the lean to have no lean at all. Lean left. Now if I hold Control and move our preview value, you can see we have our run animation. As we move across the other axes, the character begins to lean. If we slow the run down, it slowly fades out the lean to have no lean at all when we're back in the middle. Go this way, he'll lean the other way, and if we change direction whilst running, you see the character's lean changes. So next we need to go back to the animation blueprint. So I'm going to save and close this down and open up the animation blueprint. So in our animation blueprint, we're going to swap back over to the anim graph. I'm going to delete out the ground speed and BS1D idle run nodes. I'm going to replace these with a state machine. To do this, I'm going to right click and I'm going to type new state. And I'm going to select add new state machine. I'm going to click this and call it ground locomotion. And then connect up the output pin into the result. I'm going to double click the state machine to enter it and then drag out of entry to create our first state. I'm going to select add state and I'm going to call this idle. I'm going to open this up and drag in the a_bot_idle animation and connect that up. Idle. I'm going to open this up and drag in the a_bot_idle animation and connect that up. Now from the idle state, from its border, I'm going to drag out again and create a second state. This state I'm going to call walk, run, lean. You'll notice this created a new state and a transition. Then I'm going to create a second transition back from walk, run, lean to idle.
Run, how do I go back?
And create a _idle animation and connect that up.
Oh, for the breadcrumbs.
Now, from the idle state, from its border, I'm going to drag out again and create a second state. This state I'm going to call walk, run, lean. You'll notice this created a new state and a transition. Then I'm going to create a second transition back from walk, run, lean to idle. To do this, we're going to drag from the border and connect it to idle. So now we have a transition in and out. In walk run lean, I'm going to bring in the new BS walk run lean blend space. I'm going to connect it up and then bring in the ground speed variable as a get node and plug that into speed. So I now want a new variable for lean. So I'm going to right click and select promote to variable. And I'm going to rename it lean amount. Now I'm going to go back to the ground locomotion state machine and set our transitions. Our transition from idle to walk run lean is going to be when the character is moving. And inversely, I'm going to go back to the ground locomotion state machine and set our transitions. Our transition from idle to walk run lean is going to be when the character is moving. And inversely, when the character isn't moving, we're going to come back. So I'm going to double click the transition node. And in here, I'm going to bring in ground speed as a get node and then drag. Inversely, when the character isn't moving, we're going to come back. So I'm going to double click the transition node. And in here, I'm going to bring in ground speed as a get node and then drag out. And I want greater than 0. So when ground speed is greater than 0, we're going to transition into our blend space. To transition out, we're going to use the ground speed again. This time we're going to use less than or equal to 0 and plug that in. Now we can compile and save. And now we can move to our event graph to create the function for calculating lean. So to do this, we're going to create a new function by clicking the plus. And we're going to call this. And now we can move to our event graph to create the function for calculating lean. So to do this, we're going to create a new function by clicking the plus. And we're going to call this. So to do this, we're going to create a new function.
Because I'm about to go and mess this up anyway.
We're going to call this. So to do this, we're going to create a new function by clicking the plus. And we're going to call this calc lean. To calculate the lean of the character, we're going to look at the rotation of the character on the previous frame of animation to the current frame, work out what the difference is, and then determine whether the character needs to lean left or right. So to do that, we're going to right click and get our owning actor. This will get the character blueprint. I want to drag out and get actor rotation. From here, I'm then going to use a delta node. So a delta rotator. I'm going to disconnect this and swap it over to the B pin. For the A pin, I'm going to promote to a variable. I'm going to call this previous rotation. So every time this runs, we're going to be checking our previous rotation against our current rotation. And we're going to use that to set our lean amount. So I'm going to use set lean amount. And I'm going to plug that in here. So to use our rotator to set the lean amount, first we're going to split the return value amount. Use that to set our lean amount. So I'm going to use set lean amount. And I'm going to plug that in here. So to use our rotator to set the lean amount, first we're going to split the return value. We only want the Z value, so we only want the yaw of the character. We don't care at this point about the roll or the pitch. So I'm going to drag out of lean amount and I'm going to look for a node called finterp2. The finterp2 node allows us to interpolate between our current value and a target value. So our current value is going to be lean amount, and our target value is going to be the Z value from the delta rotator. We need to interpolate between our current value and a target value. So our current value is going to be lean amount, and our target value is going to be the Z value from the delta rotator. For delta time, we're going to drag out and type get world and select get world delta seconds. For the interp speed, we're simply going to set this to 2. The last thing we need to do is set the previous rotation value before we go and check it. And the previous rotation after this calculation is going to be our current rotation. So I'm going to drag previous rotation in and select a set node and then connect. Delta time we're going to drag out is going to be the Z value from the delta rotator. For delta time, we're going to drag out and type get world and select get world delta seconds. For the interp speed, we're simply going to set this to 2. The last thing we need to do is set the previous rotation value before we go and check it. And the previous rotation after this calculation is going to be our current rotation. So I'm going to drag previous rotation in and select a set node and then connect this into our set lean amount. I'm going to connect the previous rotation pin to our get actor rotation. I'm going to add a couple of reroute nodes just to generally tidy this graph up so we can read it a bit easier. We then need to go back to our event graph.
Mer. Last thing we have to do is rotate the badger on the previous rotation pin. Rotation to the pin to the rotation to the Silly Mer. How you doing, Mer? Hope you are well. Down, that goes there. Yeah. Okay.
We then need to go back to our event graph and add our count glean function to be called every time the animation frame is updated. So now we can compile and save. Is updated. Our count glean function to be called every time the animation frame is updated. So now we can compile and save. Now I can go back to our map and press play. And now when I run around and turn, you can see the character is leaning. Our expanded animation system now includes a simple state machine and a more complex blend space. In the next video, we will expand this system to add in jumping.
Ah! Look at that. It's very subtle, but it's there. Neat. Jump, 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 jump.
So far, our character has only been able to move around the floor. In this section of the course, we're going to give the character the ability to jump and eventually hover with a jetpack. First up, let's take a look at adding the jump functionality. The character blueprint class already has the ability to jump. We simply need to activate it using a jump node. In order for the player to be able to make the character jump, we need to set up a new input action in the enhanced input system. Once the character is jumping, we're going to modify some variables to improve the feel of the jump. To set up our jump, first we need an input action. So I'm going to create a new input action and call this one IA_jump CC. I'm going to open this up and make sure there is a digital ball, and then save and close. Then I'm going to go into the input mapping context and add our new input action. I'm going to set the controls for this to
super frustrating.
Face, and also the gamepad face bottom button.
Gamepad.
I'm going to save and close that down.
Bottom.
And in the character blueprint, I'm now going to add the logic for our jump. So I'm going to right click and type jump CC. I'll put that
not
down.
that it matters, but gamepad face button bottom. Okay.
I'm going to save and close that down. And in the character blueprint, I'm now going to add the logic for our jump. So I'm going to right click and type jump CC. I'll put in our input action event. And triggered, I'm going to drag out and type jump. This is all we need to do to make our character jump.
Which is ridiculously crazy!
I'm going to press space. You can see the character jump.
That is insane!
I'm going to go into the level, and I'm going to press space. You can see the character now jumps. We obviously don't have an animation, which we'll look at soon. But first I want to make the jump a little bit more interesting and a little bit less floaty.
Okay, well, something is not right.
Make the jump a little bit more interesting and a little bit less.
Okay, why is mine not working? Interval, jump spacebar. I don't think it changed anything in there too. Compiled, saved. Alright. Curious. Why is mine not working?
This is all we need to do.
This is all I need to do until it doesn't work. What did I do wrong? Inspiration triggered. Huh. Strange. Well, that sucks. What did I do wrong? What did I do wrong? Put action, jump. That's what I did. I have the wrong thing selected. Got it. Jump, 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 jump. Which, getting, like, that's crazy. Absolutely, just.
To make our character jump. I'm going to go into the level, and I'm going to press space. You can see the character now jumps. We obviously don't have an animation, which we'll look at soon. But first I want to make the jump a little bit more interesting and a little bit less floaty. So back in the character blueprint, I'm going to go to the character movement and search for jump. Under jump Z velocity, I'm going to change this from 420 to 900. I'm then going to search for gravity and set the gravity scale to 2.5. I'm going to compile and save once again and test it out. Now the jump has a lot more pop and comes down a little bit quicker. This just gives us a much more interesting jump that is a lot less floaty. Jumping is another aspect of a character which can have significant effects on how a game feels and how challenging it is to play. Part of the design process for a game involves balancing the height of a jump to the height of objects in the world, or the length of gaps the player needs to jump over. Another part of the process is making sure the jump feels right. Explore the effect that changing the jump Z velocity and gravity scale have on the experience of jumping with the character, and how they change the jump timing, distance, and trajectory. Next up, we're going to handle the jumping in the animation blueprint. With the functionality of jumping set up, the next step is to expand the animation blueprint to include the required states for jumping. We're going to create a second state machine which is going to handle the character's required animations when in the air. In order to use two state machines, we're going to use a cached pose. This is where we store the animation from one part of the graph for reuse elsewhere. The air locomotion state machine will make use of a variety of transition rules, including the automatic rule, which automatically transitions out of a state as the animation is finishing. So once again, we're going to expand our animation blueprint. So first we're going to open it up. Then we're going to head over to the anim graph. We're going to head back out and we're going to detach our state machine.
Wait, where am I?
So first we're going to open it up.
Oh, I'm in that. Okay, got it.
Then we're going to head over to the anim graph. We're going to head back out and we're going to detach our state machine. From the state machine, we're going to drag out of the pin and we're going to type cache and select new save cached pose. I'm going to rename this cache pose ground loco cache. Cached poses allow us to reuse the result of a state machine or any other part of our graph in other parts of the anim graph. So making this cache will allow us to reuse it somewhere else. I'm then going to create a new state machine, right-clicking a new state. And I'm going to call this state machine air locomotion. I'm going to connect this in and head into our state machine. I'm going to connect this in and head into our state machine. I'm going to drag out our entry and create our first state. This state is going to be called ground loco.
Loco ground.
State, we're going to use the ground loco cache. So I'm going to right click and search for ground loco and select use cached pose ground loco cache. And then I'm just going to plug this in. We're then going to create 3 new states for our jumping. So I'm going to drag out of ground loco and create a state. And I'm going to call this state jump. I'm going to drag out again to create another state and call this fall. And create a third state called land. Then going to drag from land to ground loco to create our final transition. I'm going to move these around just to tidy them up a little bit to make it a little bit easier to follow. And then we're going to go and set our animations. So inside jump, we're going to use a_bot_idle jump. Inside fall, we're going to use a_bot_fall. And then in land, we're going to use a_bot_land idle. And connect that up. Now we need to set our transitions. So firstly, we're going to go into the ground loco to jump transition. And we're going to right click the can enter transition and promote this to a variable. We're going to call this is_in_air. This variable is going to be set to true.
Actually put a question mark there?
So when the character is in the air, we'll enter our
Jesus
jump
Christ, wow.
So when the character is in the air, we'll enter our jump state. From jump to fall, we're going to make use of the automatic transition. From fall to land, we're going to once again bring in is_in_air, but this time I'm going to drag out, and we're going to search for our jump is going to be set to true when the character is in the air. So when the character is in the air, we'll enter our jump state. From jump to fall, we're going to make use of the automatic transition. From fall to land, we're going to once again bring in is_in_air, but this time I'm going to drag out and we're going to search for a not boolean. This not boolean node will take the is in air and it will return true when is in air is false. So when is in air is false, we enter our transition. For land to ground loco, we're going to use the automatic rule-based transition again. Now all that's left to do is go back to the event graph and add a check for is in air. So from the movement component, we're going to drag out and we're going to search for is falling. When the character is falling, is in air is going to be true. So I'll drag in is in air and use a set node. Link this into our existing chain, set node. Link this into our existing chain and plug this together. It doesn't matter what order we set these variables. I've just done it here for ease and tidiness. Now we can compile and save and head over to our test.
Oh, something's not happy. Jump to fall will never be taken, please. What did I miss?
Now we can compile.
The fall will never be taken, please. Something. Wait. Wasn't that supposed to have... Dragon into air set mode? This is so confusing. Okay. Lane. Ground logo will never be taken. Please click something. What? Why are you not happy?
And save and head over to our test.
It's not happy. It is so not happy.
Now when I jump, we have our animation.
I don't think mine's... Yeah. So it's never getting the land. Why? What did I do? What did you...
One issue we do have is that when we're running and we play the animation, the character lands flat-footed, as you can see here. Now, if we stop, that looks okay. When we're moving, it slides. That's what we're going to look to fix in the next video. So when the character is in the air, we'll enter our jump. A underscore easier to follow. Drag from land to ground loco to create our final transition. I'm going to move these around just to tidy them up a little bit.
What did I
A little
miss?
bit easier to follow. And then we're going to go and set our animations. So inside jump, we're going to use a underscore bot underscore idle jump. Inside fall, we're going to use a underscore bot underscore fall. And then in land, we're going to use a underscore bot underscore land idle. And connect that up. Now we need to set our transitions. So firstly, we're going to go into the ground loco to jump transition. And we're going to right click the can enter transition and promote this to a variable. We're going to call this is in air. This variable is going to be set to true when the character is in the air. So when the character is in the air, we'll enter our jump state. From jump to fall, we're going to make use of the automatic transition.
Oh, that's what I missed.
From fall to land,
They actually
we're going to
clicked
once
the
again
button.
bring in is in air. From fall to land, we're going to make use of the
transition, automatic rule based on sequence. Okay. I didn't realize they actually clicked a button
automatic
there.
transition. From fall to land, we're going to once again bring in is in air, but this time I'm going to drag out and we're going to search for a not boolean. This not boolean node will take the is in air and it will return true when is in air is false. So when is in air is false, we enter our transition. For land to ground loco, we're going to use the automatic rule-based transition again.
There we go.
Now all that's left to do is go back to the event graph and add a check for is in air.
I'm on!
In this video, we're going to improve the feel of the animations when jumping and landing. Animations can make or break the believability of a character. Something as simple as how the character animates when jumping and landing is key to providing slick player characters we are used to in modern games. One of the key focuses when setting up animations should always be the feet. If a character's feet slide across the floor when they should be running, and inversely slide when they should be stationary, we risk damaging that sense of immersion. So for our jump animation, we're going to use a blend space. So in animation, I'm going to create a new blend space 1D, select skbot, and call this bs1d underscore jump. Inside the blend space, I'm going to set up the horizontal axis to be speed, use our same minimum and maximum values we've used on our underscore, select skbot, and call this bs1d underscore jump.
Which I don't have 1D, a kind of asterisk.
Inside the blend space, I'm going to set up the horizontal axis to be speed, use our same minimum and maximum values we've used on our other blend spaces. The grid divisions this time are going to be set to 5, and I'm going to turn on snap to grid. We're going to add two animations to the graph. The first is idle jump, which is going to be placed at 100, and the second is run jump, which is going to be placed at 200. This means that when the character is travelling between 0 and 100 on speed, it will use the 2-footed jump. When it's above on speed, 200, which is going to be placed at 100. And the second is run jump, which is going to be placed at 200. This means that when the character is travelling between 0 and 100 on speed, it will use the 2-footed jump. When it's above 200, it will use the 1-footed jump. And anywhere in between, it will blend depending on the value. So I can save this and close it down, and we can go over to our animation blueprint to work this in. In the state machine, we're going to go into our jump state and replace the a_bot_ idle jump animation with our new blend space 1D. In the state machine, we're going to go into our jump state and replace the a_bot_ idle jump animation with our new blend space 1D jump. I'm going to plug it in. I'm going to bring in our ground speed variable and connect that up. We're going to go back to the blend space and delete the land state. Then going to drag out of fall and create a conduit. I'm going to call the conduit land space and delete. We're going to go back to the blend space and delete the land state.
Bye, land!
Then going to drag out of fall and create a conduit. I'm going to call the conduit land. From the conduit, we're then going to create two new states. I'm going to drag out of land and create a new state, and I'm going to call this land idle.
Oops.
I'm going to create a second state called land run. I'm going to connect both of these up to ground loco to create our transitions. And now I'm going to set the animations. So for land idle, I'm going to use a_bot_land idle. So for land idle, I'm going to use a_bot_land idle. And for land run, I'm going to use a_bot_land run. So I'm going to go into the land conduit and turn on can enter transition. I don't want to put any other rules in here, just want to make sure that we always go straight through. For the fall to land, we're going to use the is in air and not Boolean nodes in order. For the fall to land, we're going to use the is in air and not Boolean nodes in order to enter the transition. So when we're not in the air, we're going to enter the transition. Now when it comes to land idle and land run, we're going to make use of a new variable. So I'm going to go into the land run transition and promote the variable. This variable is going to be called run transition and promote the variable. This variable is going to be called movement input ? And then for the land idle, we're going to use movement input and the not Boolean node. For both the land idle to ground loco, and land run to ground loco, we're going to turn on the automatic rule-based ground loco and land run to ground loco. We're going to turn on the automatic rule-based transition. Now we're going to go into the event graph to set up our movement input check. We're going to right click and type try get pawn and use our try get pawn owner node. I'm going to drag out of the try get pawn owner and I want last movement. I'm going to choose get last movement input vector. And then from here, I'm going to drag out and type length. I want vector length. And then I'm going to drag out to create a greater than node. So when the vector length is greater than 0, movement input, which we're going to drag in and choose as set node, is going to be true. So when the player has provided movement input, which we're going to drag in and choose as set node, is going to be true. So when the player has provided input, it will be true, and when they haven't, it will be false. And that will choose whether to land with flat feet or running feet. We can compile and save and head back to our map. For testing, I'm going to make the floor a little bit bigger. This is so I've got plenty of space to run around in. Now, a little bit bigger. This is so I've got plenty of space to run around in.
I've got enough because it's a different scene.
Now when I run around and jump, we no longer have the two-footed landing. But when we land stationary, we have the two-footed landing. If I run and jump and stop giving it input, it will land two-footed. So this is working well. The alternative animations, whilst relatively simple, make a big difference to how natural the character feels as we run around. In our next video, we're going to start adding our final feature, the jetpack.
This is very fast.
In this video, we're going to implement a simplified version of the jetpack featured in the Stackerbot project. This system is still a little bit more complex than anything we've built so far, as it uses multiple functions to make the necessary changes to how the character behaves when we use the jetpack. We're going to start by adding all of the components we need, including a jetpack skeletal mesh, a Niagara particle system, and an audio component which will use a meta sound source. We will then develop the jetpack functionality by modifying the jump logic and creating a function to apply the physical effect to the character. So first, we're going to add our various components. In the character blueprint, we're going to swap to the viewport and select the mesh. Then I'm going to click Add and add a skeletal mesh. I'm going to call this Jetpack, and then set the skeletal mesh to be. I'm going to call this and select the mesh. Then I'm going to click Add and add a skeletal mesh. I'm going to call this Jetpack, and then set the skeletal mesh to be Backpack. This will place the jetpack at the character's feet to be Backpack, Jetpack, and then set the skeletal mesh to be Backpack. This will place the jetpack at the character's feet. We're going to go to Parent Socket and choose Backpack Socket. You should now see the backpack snap onto the character's back. And choose Back. This will place the jetpack at the character's feet. We're going to go to Parent Socket and choose Backpack Socket. You should now see the backpack snap onto the character's back. With that done and the jetpack selected, we're going to now add a Niagara particle system component. I'm going to call this Jetpack FX. For Parent Socket, I'm going to set Thruster Socket left, and then choose the Jetpack Thruster particle system. Should immediately see the Jetpack Thruster start playing. We're going to turn off Auto Activate. Should immediately I'm going to set Thruster Socket left, and then choose the Jetpack Thruster particle system. Should immediately see the Jetpack Thruster start playing. We're going to turn off Auto Activate. Last, we're going to select the capsule component, click Add, and add an audio component. We're going to call this Jet component. Turn off Auto Activate. Last, we're going to select the capsule component, click Add, and add an audio component. We're going to call this Jetpack SFX. I'm going to set the sound to the SFX_jetpack. And I'm going to call this Jetpack SFX. I'm going to set the sound to the SFX_jetpack and set the volume modifier to 3. And then I'm going to scroll
That
down.
sounds scary. I don't think I want to set the volume modifier.
This will give us the option to play it when we need it. Now we can go into the event graph and this will give us the option to play it when we need it.
Auto activate, where are you? There you are.
Now we can go into the event graph and rework the jump logic. I'm going to detach jump from the input action and just move it out of the way for a moment. From the jump, we're going to determine what we're going to do based on what the character is currently doing, whether it's walking or falling. So I'm going to start with the character movement component. I'm going to drag out of here and search for Get Movement Mode. And then from Get Movement Mode, I'm going to drag out and search for Switch on E Movement Mode. This node will allow us to make a decision as to what output pin we use based on what movement mode the character is in. I'm going to plug this into started rather than triggered, so that when we press jump, it only runs in when we first press it and not repeatedly on triggered. When we're walking, we're going to make the character jump. When we're falling or flying, we're going to activate the jetpack. For now, I'm just going to put in a print when we're walking when we first rather than triggered, so that when we press jump, It only runs in when we first press it and not repeatedly on triggered. When we're walking, we're going to make the character jump. When we're falling or flying, we're going to activate the jetpack. For now, I'm just going to put in a print string so we can confirm that this is working.
It's fine, I don't care.
I'm going to type jetpack on completed. I'm going to drag down and type stop jumping. Then I'm going to set a second print string because this is where we're going to turn the jetpack off. I'm going to type jetpack off. I'm going to compile this and give it a test.
Stop jumping. Jump average.
I'm going to press play, and now I'm just going to jump and then press the button, press spacebar again in midair. And you can see that when I press it the second time, jetpack on is being printed in the top left corner of the viewport. So now we've confirmed where the jetpack needs to be turned on and off, we can replace the prints in the character blueprint with a boolean that is going to activate the effects of our jetpack. So I'm going to delete both the prints and create a new bool variable. I'm going to call this jetpack active. I'm going to drag
Where's
it
your question mark?
set node and plug this into falling and flying. I'm going to set active to true. Then I'm going to duplicate that node and plug it into our completed and our stop jumping and set it to false. To apply the effect to our completed and true, then I'm going to duplicate that node and plug it into our completed and our stop jumping and set it to false. To apply the effects of the jetpack, we're going to use a function.
Oh,
I'm going to create a new function and call this update jetpack. In here, I'm going to bring in jetpack active and use that for. I'm going to create a new function to plug it into our completed and our stop jumping and set it to false.
okay.
To apply the effects of the jetpack, we're going to use a function. I'm going to create a new function and call this update jetpack. In here, I'm going to bring in jetpack active and use that for an if node or a branch. I'm going to plug this in, and from true, so when jetpack is active, I'm going to launch the character with the launch character node. I'm going to set the launch velocity to 0, 0, 120. Then we're going to go back to the event graph and put this 0, 0 character with the launch character node. I'm going to set the launch velocity to 0, 0, 120. Then we're going to go back to the event graph and put this function as part of the event tick chain. So I'm going to drag this in.
Tick way up. Wait, where is that? It's way up here.
And connect it to event tick. So this function will be checked on every tick. When the jetpack is active, it will launch the character. Function will be checked on every tick. When the jetpack is active, it will launch the character upwards. I'm going to compile and save and head over to test. When I jump, it works as normal. When I jump and press spacebar a second time, it fires the character up into the air. Now the response we've got isn't quite what we're looking for. So I'm going to get the character up into the air.
Blat.
Now the response we've got isn't quite what we're looking for. So I'm going to go back to the character blueprint and make one small change, which is turn on Z override. Compile and save once again and give it another test. This time when we press jump a second time, the result is much more appealing. We still have a problem that the jetpack continues to work infinitely. We need to fix that next. To limit how long the jetpack works for, we're going to set up thruster time. I'm going to start by creating a new variable. So over in the variables list, I'm going to click the plus, and I'm going to call this thruster time. I'm going to change the variable type to float. I'm going to create a second float, and this one's going to be called thruster time max. I'm going to compile and then set both the thruster time and thruster time max defaults to 2. This is going to be how long the jetpack is going to work for. In our update jetpack function, we're going to reduce thruster time on every tick. So, I'm going to move launch character out of the way and disconnect it for a moment. Then I'm going to bring in a thruster time set node and plug this in. To set thruster time, we're going to start with the existing thruster time, and then we're going to minus or subtract world delta seconds. World delta seconds is the time between the last tick and this tick, so that will give us how long the jetpack has been in use. I'm going to plug this in, and the last thing to do is check whether thruster time has reached 0, and if it has, turn off the jetpack. So to do that, I'm going to bring in thruster time, and so that will give us how long the jetpack has been in use. I'm going to plug this in, and the last thing to do is check whether thruster time has reached 0, and if it has, turn off the jetpack. So to do that, I'm going to bring in thruster time, and I'm going to drag out a less than or equal to 0. Then from here, I'm going to create a branch equal to 0. Then from here, I'm going to create a branch. I'm going to plug the branch in. So if thruster time is less than or equal to 0, returns true, we want to take jetpack active and set it to off. So we compile and save. Now you can go over to the map and give it a try. Now when I jump and press space, so we compile and set it, returns true, we want to take jetpack active and set it to off. So we compile and save. Now you can go over to the map and give it a try. Now when I jump and press spacebar a second time, the jetpack works for a while and then I fall back to floor. I can't at this point, however, reuse the jetpack because we need to build a function to reset the jetpack. So back in the character blueprint, we're going to create a new function, and we're going to call this function toggle. So back in the character blueprint, we're going to create a new function, and we're going to call this function toggle jetpack. We're going to give the function 2 input parameters. The first one is going to be called reset, and the second is going to be called activate. Both of these can stay as Boolean variables. So I'm going to drag out and we'll create a branch. I'm going to connect the branch to reset, and then if reset is true, we're going to set thruster time to equal thruster time max. This will reset thruster time to the value of 2, which is the default for thruster time max. From false, we're going to set jetpack active to equal whatever the function call's input parameter is. So if activate is true, it will set to true, and if activate is false, it will set to false. And if input jetpack from false, we're going to set jetpack active to equal whatever the function call's input parameter is. So if activate is true, it will set to true, and if activate is false, it will set to false. Let's tidy things up a little bit so it's a bit easier to read, and then we can compile that. Next, we need to replace wherever we've set the jetpack to be active with the toggle jetpack node instead. So back in the event graph, I'm going to delete both of the set jetpack active nodes and replace them with toggle jetpack nodes instead. So from falling and flying, we're going to activate the jetpack. From stop jumping, we're going to deactivate the jetpack. We also need to go into update jetpack and replace this. From stop jumping, we're going to deactivate the jetpack. We also need to go into update jetpack and replace this one again with toggle jetpack. We also need to go into update jetpack and replace this one again with toggle jetpack and make sure that it's off. We have one more thing to do, which is to reset and make sure that it's off. We have one more thing to do, which is to reset the jetpack. We're going to reset the jetpack when the character lands. So if we look for event landed, we have an event on landed node. From this, we can use our toggle jetpack and plug this in. And when we land, we're going to reset our jetpack and deactivate it. So now we can compile and go and give it a test. And plug this in. And when we land, we're going to reset our jetpack and deactivate it. So now we can compile and go and give it a test. So if we jump and hold it down, the character will eventually fall, and we can repeat that over and over. With the functionality set up, in the next video, we'll look at activating all of the visual and audio elements, including animations, particle systems, and sounds.
Neat. Strange. What is that? I got something up here a second. That's weird. I have to call him to figure out what the heck that is. Okay.
In this video, we'll be linking in the visual and audio components when toggling the jetpack on and off. We will be expanding the jetpack toggle function to provide an increased amount of air control to the player when the character is in the air, as well as activating and deactivating the visual and sound effects. Lastly, we'll modify the air locomotion state machine to make use of Stackerbot's hovering animations. Let's expand the toggle jetpack function. Inside the character, back in toggle jetpack, we're now going to put an if from the jetpack active. To set up we're now going to put an if.
Where is this? Update jetpack.
Inside the character, back in toggle jetpack, we're now going to put an if from the jetpack active.
Interesting. What am I missing? Why is yours very different than mine?
Bring animations. Let's expand the toggle jetpack function.
Update jetpack. That. Oh no. Okay, mine is. Okay, that is the same.
Inside the character, back in toggle jetpack.
Oh, toggle jetpack.
We're now going to put an if from the jetpack active. To set up the air control, we're going to need to bring in our character movement, drag out and type set air control.
Character movement.
Our character movement, drag out and type set air control.
Air control? Set air control. Oh, I wonder if that allows you to navigate while in the air. That makes sense.
When the jetpack is true, we're going to set air control to 5. Going to duplicate it with Control D. When jetpack active is false, we're going to set air control back to 1. So the VFX, we're going to bring in jet back to 1. So the VFX, we're going to bring in Jetpack FX. Drag this out and type activate. When it's true, we're going to activate. When it's false, we're going to deactivate. For the sound, we're going to drag in Jetpack SFX, drag out and type play. When Jetpack is active,
Oh, Jetpack SFX. Play.
and type play. When Jetpack is active, we're going to play the Jetpack sound effect. For the inactive, we need to do things a little bit differently. First, we need to drag out and type is playing. We need to check that the sound is playing first before we can do anything with it. I'm going to put in a branch from is playing and plug this in to our false logic. If it is playing, we want to trigger the Jetpack off trigger within the meta sound. So I'm going to drag out a Jetpack SFX and type trigger. The execute trigger parameter node allows us to call triggers from the meta sound. The execute trigger parameter node allows us to call triggers. We want to trigger the Jetpack off trigger within the meta sound. So I'm going to drag out a Jetpack SFX and type trigger. The execute trigger parameter node allows us to call triggers from the meta sound. I'm going to plug this into true. The in name is going to be Jetpack off. I'm going to tidy this up a little bit with a reroute node just to make it a little bit easier to read. Now we can compile and save and go and test it. This up a little bit with a reroute node just to make it a little bit easier to read. Now a reroute node just to make it a little bit easier to read. Now we can compile and save and go and test it. When we jump and press the space, we get both our visual effects and our audio effects. When the jetpack stops, the sound effects stop. We get both our visual. I'm going to tidy this up a little bit with a reroute node just to make it a little bit easier to
name jetpack off.
read. Now we can compile and save and go and test it. When we jump and press the space, we get both our visual effect and our audio effects. When the jetpack stops, the sound effect stops. Next up, we need to go and expand our animation blueprint. We need to create some new states for our jetpack. So in the air locomotion state machine, we're going to go ahead and create 3 new states. So I'm going to right click and click. I'm going to right click and choose add state. And the first state is going to be called start jetpack. I'm going to drag out of this and create a new state and call this one jetpack hovering. The third state is going to be called end jetpack. Next, we need to link these 3 states into our existing state machine. We want transitions from jump to start jetpack, from fall to start jetpack, from start jetpack to fall, from end jetpack to fall, and from end jetpack to land. Now we need to set the rules for our transitions. Firstly, jump to start jetpack. For this, we're going to promote the variable and call it is hovering ? And then go back to the state machine and use the same transition rule for fall to start jetpack. This time, we're just going to drag it in. From start jetpack and use the same transition rule for, and then go back to the state machine and use the same transition rule for fall to start jetpack. This time we're just going to drag it in. From start jetpack to fall, however, we're going to use a not boolean. So I'm going to bring in is hovering, search for our not boolean, and connect it up. From start jetpack to jetpack hovering, we're going to turn on automatic rule, and from jetpack hovering to end jetpack, we're going to use the is hovering and a not node once again.
Not node, yes.
From start jetpack to jetpack hovering, from start jetpack to jetpack hovering, we're going to turn on automatic rule, and from jetpack hovering to end jetpack, we're going to use the rule, and from jetpack hovering to end jetpack, we're going to use the is hovering and a not node once again. And a not node once again. For our last 2 transitions, we have end jetpack to fall, which is going to use is in air. And from end jetpack to land, we're going to use is in air and a not node. Use is in air. And from end jetpack, which is going, for our last 2 transitions, we have end jetpack to fall, which is going to use is in air. And from end jetpack to land, we're going to use is in air and a not node. Now we need to set the animations that can be used in each of the states. For start jetpack, we can use a_bot_ that can be used in each of the states. For start jetpack, we can use a_bot_hover_start. Jetpack, we can use a_bot_hover_start. For jetpack hover, we can use a_bot_hover loop. And then for end jetpack, we can use a_bot_hover end. Now all that's left to do is set the value of is hovering in the event graph. From the try get pawn owner node, we're going to drag out and type cast to BP and select cast to BP stackbot. This is going to be dropped in at the end of our chain. As with before, we're going to put some reroute nodes in to tidy BP and select cast to BP stackbot. This is going to be dropped in at the end of our chain. As with before, we're going to put some reroute nodes in to tidy things up. From the cast to BP stackbot node, we're going to drag out and type get jetpack active. From this variable, we can then set is hovering. Now we can compile and save and go and test it. We can then set is hovering. Now we can compile and save and go and test it. Now when we jump, we have our normal animation. When we jump and hover, we get the hovering animation. We now have an animation. When we jump and hover, we get the hovering animation. Now when we jump, we have our normal animation. When we jump and hover, we get the hovering animation.
Silly Mert.
We now have a jetpack system that gives us a bit more control of how the character behaves when in the air. As mentioned at the start of the previous video, the system is a simplified version of the one available in the Stackabot project. The Stackabot BP_bot character has a few extra features, including using an external float curve to control the amount the jetpack pushes up the character. It also controls the length of the flame coming from the jetpack, as the force changes over time. It's worth taking a look if you want to expand the system we've just built. In the next video, we're going to playtest our final character and make sure everything is working.
Didn't we just do that?
Now we've built all of the systems, let's take the opportunity to test out each of the features that we've built. The character should be able to run around the world and continue running whichever way you face the camera. Changing the input should keep the camera facing the way it was before, but the character should change direction. When the character stops and you move the camera should pivot around the character. We also built a jump system, and the jump system included a jetpack. As you can see, I've set up a few platforms to test out my jetpack and jumping.
Bye, platform. I miss you.
Try setting up a few platforms for yourself so you can have some fun with your third-person character. We've now come to the end of this course. Based on the lessons taught in this course, you're now able to select appropriate static meshes for use in a player character, utilise the enhanced input system, create a variety of different third-person camera solutions, develop animation blueprints using state machines, blend spaces, and cached poses, and build and expand a jumping system to include a jetpack. Thanks for watching the course. I hope you've enjoyed learning about building a third-person character from scratch and have loads of fun creating your own characters from what you've learned here.
Neat. I wouldn't exactly say that I know how to do all these things, just that I have done them. Because learning them is a whole nother matter. That's repetition. Which, going through multiple tutorials, I start to find things that are, it's like, okay, I remember this, I remember that. It's like, okay, this is new, or I remember this, but I don't remember it well enough. So I was like, it's a learning process. It's a learning process. I want to tackle this one. It's got an hour long, which my timing is never going to be the same as theirs because I pause and rewind and go back and forth, stuff like that. Let's see. Did that. Oh, this is like a 2-hour live stream. And we did that. Okay. So check, check, check. Not gonna watch that. Check. I've done this one. This is completed. I wonder if there's a way to be like, bam, I did this. Like I want to actually have like something tied to my account that's like, I did this. Not necessarily for others to see, just so I remember myself. Oh. Okay. Let's see, we did that one, we did this one. That's what we did, that we did. This is, that's a resource. This one, I don't think we're ready to do that one yet. This one will, I think, this will come later, that'll come later. Blueprint debugging, that's what we use for now. 34 minutes. Discover various methods to identify and resolve bugs to your blueprints. Use print string breakpoints. Debugger when it. Let's do this one. I think this is going to be a good one to do. Yeah. Character Mars, heyo, how you doing? For the description. Hello. Game dev is not necessarily my go-to stream content. I bounce between actual gameplay and sometimes I will stream my game development stuff. Sometimes I simply cannot. But I thought it would be fun to share my progress of learning Unreal. So that's why I'm doing that. Otherwise, actual gameplay content, I tend to lean towards survival games, strategy games, tactics, factory games, that's short. I've been doing GH, green H. Might consider the forest. Previously, I was doing Age of Wonders. Brain. What is the latest? 4? Oh, yeah, Age of Wonders 4. I really want to get back into Stellaris. Yeah, I'm also a really big achievement hunter, so a lot of the stuff that I work on it's like I'm going after achievements. But I do enjoy game development as well. But hello, welcome. How are you doing? Hope you are well. My plan is actually to do gameplay, and probably I would guess about an hour to 2 hours is probably when I will start playing the game again. I don't know if you were asking because you want more game dev or if you want more gameplay. But one of the reasons I was looking for a shorter tutorial was because I plan on being done my brain's going to shut down in about the next hour. Plus, that's when someone else gets off work and we got to figure out dinner, and then once dinner's settled, then I settle into play for the rest of the day. Cool, excited for the game dev stuff, but cool to hear you also do a lot of variety gameplay. Yeah. Yep, I bounce around a lot. Probably gonna be doing GH for quite a while though. Oh my gosh, the achievements take a while. But I'm having a lot of fun with it. Yeah. Do you do any game development stuff? Are you familiar with things? Are you curious about things? What's your interest? And I am going to change the runtime, use breakpoints, visual data. I think learning how to do this debug stuff is probably going to be a good idea moving forward anyway. So I'm gonna try and knock this one out before we're done for the day.
Hello, my name is Matthew.
Although this module is conclusion. I hope that this isn't just straight up information. I hope this is actually a straight up, like, literally walk you through stuff and have you do things. So we'll see. If it ends up that this is purely informational, I'm not gonna sit here and just watch videos. I can do that off stream. So we'll see.
And welcome to the course on blueprint debugging. We're going to take a look at a few of the ways to debug your blueprints to help you identify your problems so you can work on fixing them. First, well, what is debugging? In computer programming and software development, debugging is the process of finding and resolving bugs. As you are working on your projects, you may run into unexpected results. So I wanted to take some time to show you some of the methods available to you to try and help you find these issues so you can fix them. Do note this is just a top-level basic introduction to blueprint debugging. There are more advanced topics that are not covered in this course. What are we going to cover in this course? We're going to start off with looking at print string, which gives you the ability to put information onto your viewport as well as your output log, which is useful when you need to see some data. We have breakpoint debugging workflow. This is our standard way to debug a program by pausing it while it's running. You can then look at all the information while it's running and step from node to node and see exactly what process is occurring. The Blueprint Debugger window can be used to see all of this information in an organized location, and it's a great way to see things happening in real time. We'll take
Character Mars, you do game dev, just realizing it's also be fun to hear from. Oh, plus, okay. It's also fun and insightful to hear and watch others. Oh yeah, absolutely. So it's a great way to learn that I've found. What how long you've been doing game dev, what engine do you use, or engines? And have you done... Are you purely game development? Have you done enterprise development? And are you more front end, back end? You know, if you care to share, always happy to learn more. Meet someone new.
You can look at visual program information onto your viewport as well as your output log, which is useful when you need to see some data. We have breakpoint debugging workflow. This is our standard way to debug a program by pausing it while it's running. You can then look at all the information while it's running and step from node to node and see exactly what process is occurring. The Blueprint Debugger window can be used to see all of this information in an organized location, and it's a great way to see things happening in real time. We'll take a look at visualizing some of this data using the debug shapes so we can see what it looks like inside of our project. And then we'll touch on enabling and disabling nodes in the editor. Rather than rewiring your project when you need to make a change or test something, you can disable and enable nodes and it will skip past them.
Ooh, that's cool. I definitely need to know how to do that. Seems like stuff like this, I don't know how to do that yet. But a lot of this, and Unity, yeah. It's like I've done debugging in Unity. Mainly Unity, all over the place on it, but mainly gameplay systems. Also curious about Unreal Jump, so this was super, super topical, right? So I've used Unity for probably... I've used Unity professionally for about 2 years, and I've used Unity personally for over a decade. I mean, if it dates me, I remember having to work with Unity's original UI system. Yeah, that was fun. Their new one is really nice. If you haven't used the UI toolkit, it is amazing. But having said how much I have used Unity and how much I like Unity, and I have enjoyed Unity. I do a little. Unity has a lot of really cool stuff. I definitely have had a couple moments in the past week where I have started learning Unreal, where I may have had a passing thought of, oh, what have I been doing the past 10 years of my life? Unreal has some pretty insane stuff, I gotta say. I admit I am blown away by some of the stuff that I've seen. So if you're looking to dive into things, it might be worth looking into. If you would like, I can also reference the stuff that I have started with. There is in particular this, I cannot emphasize how useful it was coming from Unity and just watching all these videos, which you gotta sit through and watch a bunch of videos, yes, but this. These videos, cannot stress enough how much they helped me at the very beginning. Like, I didn't even install Unreal. Like, just not even touching it. I don't want to do anything until I have done some research and watched some stuff. I watched all of these videos, except for the last one, which is not relevant to me. Unreal Editor for Fortnite for Unreal developers. It's not relevant to me. I don't do Fortnite. But I watched all the others, and it's a very high level overview of everything, and it basically walks you through these. Wait, what? Huh. Interesting. I can't have these as... Okay, something's weird. Download the schematic. Interesting. Okay. Well, something to know is if you try to save these in tabs, apparently it's not going to let you. I'll probably have to download them and then load the tabs. Anyway, these flowcharts. I can't say that I've really referenced them since I've watched them, but even though I didn't take in everything and I'm not going to remember all these little details, having gone through these videos that literally each of these videos takes one of these flowcharts and they walk you through all of the process. Like, this is how the engine works, this is how animation works, and this is the step, this is the flow, it's the flowchart. It's literally, it walks you through every component of it at a very high level. And it was very useful to be like, oh, okay, so that's how that relates to Unity, and it's very, very useful. Definitely recommend that. The UE docs are actually useful. I feel like Unity docs are... Oh! DDXDT. Thank you for the follow, much appreciated. Still have the duplication, don't know why. Dead Sea Scrolls Unity docs. Yeah. I've had some good luck with Unity docs. I don't know much about the actual Unreal docs. I haven't really gotten far enough to actually use their docs. I am just going through the tutorials, notably specifically the official tutorials. I will show you something else if you're interested. Also, if I'm pushing too much information on you and you're not interested, just let me know. You can stop me. Learning Epic Games. This. Yes. Okay. So, if you go... Info is all good. Yeah. Also, DDXTD, how you doing? Hope you're well. So let me pull this URL for you. But you go to their official, like community learning resource thing, and there's a couple filters that really work well. So specifically Epic Games, so you're getting their official content. You want courses, learning paths, tutorials. I tick off live streams, talks, demos, and knowledge bases. They're useful, but there is such a thing as too much information right out the gate. You gotta pace yourself and be like, start with the basics, really get a foundation before you try to go into doing anything. Oh, and coming from Unity, one of the things I can't stress enough, and I still don't have a complete full grasp on, I'm working on it, is what they... I'm going to close all these because these are apparently useless now. Let me see if I can find it. Because it is relevant. But it's their naming convention is weird. If you're coming from Unity, the best I can say is it's very weird, but it kind of makes sense. And I'm starting to learn it from what they call actors and pawns and actors, pawns. It's like I said, I'm still working my head around it all. And they don't have an immediate translation into what Unity does. They kind of sort of do. I think it might be a different tutorial. Blueprints world building, maybe under world building. But these videos, they'll walk you through it. They aren't going to walk you through how they translate to Unity, but some of this stuff you can get a feel for. It's all good. It's good that they get the nomenclature battle up front. I would love to have... I imagine a doc exists somewhere that really helps translate things from a Unity developer to Unreal. Placeable act... Okay. I think this might be it. Audio actor. So, best I can tell, an actor is a game object. That's the best translation I've gotten so far, but don't hold me to that. That's just where my current mental state is. But also a pawn is... I think a pawn is a type of actor, but a pawn is something that you can control, or that could be controlled by an AI. And I think a character... I forgot, but like there's all these different terminologies that it really matters. Like actor, pawn, character, all these things are my brain. I'm working on it. I haven't quite learned things enough that I can reiterate them. So I'm still early. I'm still learning. But it's something that you're gonna have to wrap your head around. It's gonna throw you for a loop. At least it is me. But man, some of the stuff though. I'll go to day 3, right? Technically, it's a little. It's more days than that. I started watching videos almost 2 weeks ago, but like actually installation and working in the engine is 3 days. But like starting watching those videos, yeah. But man, like I wish you could. Like I don't do actual camera. I only do face rate. But like if you could see my facial expressions, just like, oh my gosh, what the thing can do is absolutely insane. Like the tutorial that I just went through. We're building a character controller from scratch. And it's like, you know what? Here, one of the things I can show you, just as a simple example. Where did my thing go? It's like, oh, okay, you want to, DP, also, this blueprint, event graph thing also takes some getting used to if you're C#. I haven't done visual scripting before, but okay. So this input node is basically coming from the input controller. It's like, okay, we have mapped our jump control to spacebar. That's done elsewhere, and it's like, okay, you want your character to jump. And literally, there's a jump function. It's already there. So you don't have to write anything. You don't have to do anything. It already exists. It's just, oh, okay, you want your character to jump? Here, call jump. It's like, what? Oh. Okay. Like, stuff like that, it's just like, things that just already exist blows me away. A lot of parts of the character movement and certain animations. There was a what was it? It was like I don't remember. My brain went off, but it's just it blows me away how much is just already there for you to use. Yeah. Anyway. Prototyping yeah. Yeah, really it is. It's crazy. Another point of view that I recently had gotten, and for somehow for all the years I never knew this little tidbit of information. If you didn't already know, Unity is built and owned, ran by kind of the corporate guru style. It is Unity is an engine written from an enterprise development standpoint. It was built to be a game engine from a enterprise development standpoint. That's the best I can say. But Unreal is a game engine built by game developers for developing a game. Like, Unreal was originally built as a game engine for Unreal. Now Unreal is their flagship is Fortnite. So Unreal, the game engine, is using their own product to build their own games. Unity doesn't have that. Unity is a game engine built for game developers by enterprise developers. Unreal is a game engine built for game developers by game developers. And you can kind of tell in some ways. And as I was getting deeper into it, it's just like, okay, I see. Yeah, anyway. I am going off on like 20,000 tangents. Can you tell I'm a little excited about this? Like, Jesus, it's crazy. And I'm wishing I had done this sooner. Alright, I was pulling a link for you. Courses, oh yes, for beginners. Bam, this one. So, you have to, like, copy the whole text. You can't click the link because it breaks the link because of the comma there. But this is with all the filters enabled. And it's Epic Games, courses, learning paths, tutorials. Learning paths are the things that I was doing, the little, do this tutorial, then that tutorial. It's like a group of tutorials. And then for beginners, toggled on. You want that. And be careful not to just like jump right into actual deep content, lower level content, like hair card generator. You probably don't want to start there. Start with some basics first. But this is a great diving board start point. And I can give you a bunch of other links of what I have done myself. It's like prior to even installing Unreal, I started watching all of these videos. Day one, this was the installation and your first hour in Unreal. Day two, third person sample stack. Oh wait, no, wait, hold on, that's wrong. Where's the actual? Okay, this is wrong. That's not the right link. Where was the video? Where's the tutorial that I did? It was this, your first game. That. That's wrong. Your first game in Unreal Engine 5 was what I did the second day, and then today is what I've been working on. So, yeah. My brain's going like 5,000 miles an hour right now. Oh. I recommend at least checking it out. I'm not going to say that one is necessarily better than the other yet, but it is exciting and different. Yeah. I haven't gotten into actual C++ code writing yet. Like, I've done all of this stuff I've done. I haven't touched a single line of code, which is insane. But I do plan on actually learning C++ as well, because I'm proficient with C# and Java. Not that that's relevant, but I'm an enterprise developer by trade. So familiar with other languages. Brain.
For the project with this course, I am using a third-person template in the editor. Rather than rewiring your project when you need to make a change or test something, you can disable and enable nodes and it will skip past them. There is no included project with this course. I am using a third-person template. I'd recommend trying this in your own project for learning experiences. You should be familiar with the basics of Unreal Engine before continuing with this course. With that said, seeing your data as you work with it is a quick way to try and verify a possible problem. And by using that print string node, we can easily do this.
Okay, so it sounds like there's no set project, but I could probably use the project I was just working on to follow along, it sounds like. So we could probably still do that.
When we run into something not working as
This I already know how to do. I've
getting
seen it in a
access
few
to that
videos
data
already.
to quickly
But
look
we'll
at
watch
it
through
is
it
a good
anyway.
first step to debugging our program. It also helps us determine if we actually have a problem. Verifying that we have a problem and where it might be is where we should start, and we can use the print string node to do just that. I have a sample blueprint I created, so I can show you the print string node. You can access it like any other node by just right-clicking and looking for print string. You'll notice it says development only at the bottom. That means this will be compiled out and ignored when you have a shipping build meant for testing purposes like debugging. By default, to use it, we simply want a string. We can put it in on the input part, or we can type it in. This is the string that will be shown on the screen as well as the log by default. Let me go ahead and show you an example of this. We'll hook this up to the begin play. I'll hit play, and on the top left we can see it says,
it disappears.
hello, and then it goes away. There are advanced options. If we click the advanced options, and we can find we have print to screen and print to log by default. If we want, we can go to our output log, and then I can search for print string.
Thank you for the lurk. If you ever have questions in the future, please do not hesitate to ask, even if I'm doing something else that is not in the game development category. And then thank you for the follow, muchly appreciated.
And I can see at the bottom that we've logged to the output log the message hello, which is part of our print string. You can adjust the color for your print string. This is useful if you have multiple print strings. You also have duration, so how long that print string will remain on the screen. 0 is 1 frame, and the rest of it is in floats for seconds. And lastly, we have key. Key is a unique identifier, so that way you can actually have it displayed on the screen once and then continue to update the same part. Let me show you a few different changes here. So I'm going to change the color. I'm going to change the duration. And then I'm going to add a key. Let's go ahead and hit play to test that again. Now we can see it says hello in red in the top left, and it's going to hang out for 4 seconds. The key is useful if we need to change something. I'm going to disconnect this from the begin play and hook this up to my tick, and we'll see what this looks like. We can now see it says hello in the top left, and it doesn't disappear after a certain amount of time. It also doesn't fill up our screen, where if we didn't have the key. If we remove the key and we play it again, you'll notice we get a repeated
Oh!
every tick.
Oh, that's okay. I get it. That's what the key does.
Or every frame, we're printing out hello and letting it last for 4 seconds.
Okay.
Let's put our key back, and let's print out something that changes every frame. Let's say something like our elapsed time for the game start. We'll put this into our input string. It'll convert it automatically for elapsed time
what
for
did
the
they
game
just do?
start. We'll put this into our input every frame. Let's say something like our elapsed time for the game start.
Whoa, which? Okay. Real time seconds. So you aren't going to explain how you did that, but I know how to at least. Print that. Okay.
We'll put this into our input string. It'll convert it automatically for us and hit play. Because we're using a key,
What, did you not
it'll
compile?
convert it automatically for us and hit play.
Oh.
Because
Does it automatically compile when you do that? Cool. Where'd it go? Do that. Why do I not have mine? What did I miss? What am I doing wrong?
Put string, say something like our elapsed time for the game start. We'll put this into our input string.
Get real-time seconds.
It'll convert it automatically for us and hit play. Because we're using a...
Okay. Oh! Begin... Oh, I'm not... Stupid, I'm an idiot. That's not the right thing. I need it here. Also, we just broke our jetpack, but that's fine. Aha! Okay, cool. Now we do this, and blah, 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 blah. Disable all screen messages. Okay, I don't care.
a key, every time it goes to print this string, it's going to replace the previous value that was using that key. So in this case, we have a timer counting.
AFK a minute. I gotta answer this one. Okay, that was an important call, but interesting. So, I'm gonna check something. I need to deal with an RL thing for a moment. Yeah, that's not gonna work. Okay, I'll have to deal with that. I'll figure that out tomorrow. Okay, sorry. Anyway, where was I?
And if we were to remove the key, you'll now see we have it counting up, but we are continually adding a string would be helpful single time. Let's go ahead and take a look at an example of when print string would be helpful. It's useful when we need to quickly get information. Here's my sample project that I'm working on, and I have a nice little menu. When I click Start Game, I should be able to start my game and play with my character. Unfortunately, I cannot move my character. None of the input seems to be getting to the character. I can move around my arrow keys, but nothing's happening. We need to figure out why. Now we can go ahead and walk through everything and try to figure it out, but let's break this down to the basic essential. The input system takes an input, in this case from our keyboard, and passes it along to our player. If we look at our player has input events, for example, move forward and backwards, that adds movement. So let's actually see if this is working. We can use the print string to verify that we're actually getting input into this character. Let's go and change the string to something like input, and we'll simply hit play and see what happens. We can see we're now getting input into our character, but when we test it, we still can't move. So we know this part is being called. So what's next? Well, we drive our input based on our values. Is our value changing? When we push our keys, do we get a different value? We'll plug this into our input string, for example. As this is for testing purposes and we're debugging, we can mess up our code a little bit. It doesn't have to look pretty because this is temporary. We'll hit play again. We can see we're getting 0.0, so there's no input on any of the axis. And when I test with the keyboard, it's not changing from 0.0. So while this code is being called, and we verified it with the print string, no actual input or axis value changes are happening. Now we can verify that we should have that working by going into our input settings. And if we go down to our axis, move forward, we can see that W and S
This
should
is
be giving
the
us
old
values of
input
1
method.
and -1. By using print string, we've drilled down to the basics of the understanding of where our problem may be coming from. This code is supposed to be running, but our axis value isn't actually getting any data. And that axis value is driven by our W and our S key for our move forward and our move backward, which means our W and our S key is not being sent to our player. As I'm the developer working on this helps me. Their axis value is driven by our W and our axis. The basic should be giving us values of 1 and -1. By using print string, we've drilled down to the basics of the understanding of where our problem may be coming from. This code is supposed to be running, but our axis value isn't actually getting any data. And that axis value is driven by our W and our S key for our move forward and our move backward, which means our W and our S key is not being sent to our player. As I'm the developer working on this helps me remember something I've done recently. I added the menu. Part of adding the menu was I need to make sure that I could click on it by setting the input mode to the user interface. When I open up my main menu widget, I can look at it and I can see. At some point, I set my input mode to UI before I show the mouse cursor when this main menu is created. When I click on my quit button, I'm hiding my mouse cursor and removing my widget, but I'm never setting my input back to game only. I've gone ahead and adjusted my code, and let's test it out. We'll hit
Interesting.
play again. We can see I'm still printing out 0.0 for my axis values. Let's go ahead and start our game. Let's move our character, and now we have input. And if I use my W and S key, we can see our character moves and those values change. So now the input is getting properly in, and we can see the print string updating appropriately. Quickly and easily putting data on our screen is a good way to identify a potential problem. But what do we do once we have that information and we want to find out why it might be happening? Well, we can randomly look and hope we remember, or by using breakpoints and a more familiar debugging workflow, we can pause our program while it's running, look at the data live, and walk through our code as it executes to try and pinpoint any problems. Once we find and identify a possible problem, we might want to see how our program is being executed to try and see where exactly the issue might be happening, and that is when breakpoint debugging and execution watch comes into play. We'll go ahead and hit play to look at our example. We can see at the top left I have 500 being printed out. That is the speed of my current character. The issue is when we jump, it's supposed to slow the character down, and then after 2 seconds, it's supposed to go back to full speed. But we can see no matter what, we're getting output that slow speed is triggering when I jump, but we're not speeding back up, and we're staying at 300. So why is this happening? We go through our code, we can see our event tick is printing out our speed, and our jump code seems pretty simple. We jump, we set the walk speed, and we print out slow speed. We stop jumping, we wait for 2 seconds, we set our max walk speed back to 500 and print out full speed. But this bottom part is never firing off, and we don't know why. We did our print string, but they're just not firing. Well,
it's right there, I see it!
Background here. I can go
but I know what they need to do.
It's going to fire it off into a new window, which we can see here. Now, when I push the jump key, we're going to see some action in the background. We can see a very quick flash.
Alright, that's cool. Wait, okay, I need to... Okay, first off, I'm going to get rid of all this. I don't need this. Okay. How do I... There we go. Move you over here so I can actually see some of this. So I'm not... Why am I not seeing? Event press, player control. That's not relevant. Did they do something to turn that on?
But this bottom part is never firing off, and we don't know why. We did our print string, but they're just not firing. Well, let's watch the execution of this in real time. So I've got this in the background here. I can go ahead and hit play. Play is going to fire it off into a new window, which we can see here. Now, when I push the jump key, we're going to see some action in the background. We can see a very quick flash of some red lines. Now let me close this example, and let me move this up to something that actually fires off every tick. Now we'll hit play again. When your blueprint is executing, the blueprint view here will show you the actual live execution. Our input for our camera is on the axis, which means every tick it's going to be checking for the value and updating. So we can see that red wire, it's firing every frame. When we go back to our jumping, because it's such a quick event for the jump, we just see that quick flash. The nice thing is, this actually led us to the answer of the problem. We can see the jump, and it's going all the way to the print string. But when we let go, stop jumping stops at the stop jumping. It doesn't make it to the next part. And that's when we notice we never actually hooked up our delay. Now if we were to test this, now we see the delay counting down, and we can see the execution for the rest of it. And we can see it says slow speed and full speed with 500 back to the normal, and we have our normal speeds. And if we were to test this,
why is mine not doing that?
I can go ahead and hit print. Well, let's watch it. Set the walk speed, and we print out slow back to 500. Our print string, but I can go ahead and hit play. Play is going to fire it off into a new window, which we can see here. Now when I push the jump key, we're going to see some action in the background. We can see a very quick...
Yeah, see, mine doesn't do that. And then they had, like, the whole... What? So, I'm gonna show... I wonder if you... Do you need to have one of these selected that they didn't specify? No? I wonder if maybe do I have to have BP stack bomb. Oh, because that's that. Oh! Wait, why did they say to do that?
We're getting output that slow is happening. We go simple. We jump, we set the walk speed, and we print out slow speed. We stop jumping, we wait for 2 seconds, we set our max walk speed back to 500. And
they never tell you to do this, or I missed it.
Is never firing off, and we don't know why. We did our print string, but they're just not firing. Well, let's watch the execution of this in real time. So I've got this in the background here. I can go ahead and hit play. Play is going to fire it off into a new window, which we can see here. Now, when I push the jump key, we're going to see some action in the background. we can see a very quick flash of some red lines. Now let me close this example and let me move this up to something that actually fires off every tick. And we'll hit play again. When your blueprint is executing, the blueprint view here will show you the actual live execution.
Look at that.
Our input for our camera and our player is on the axis, which means every tick it's going to be checking for the value and updating. So we can see that red wire, it's firing every frame. When we go back to our jumping, because it's such a quick event for the jump, we just see that quick flash. The nice thing is this actually led us to the answer of the problem. We can see the jump and it's going all the way to the print string. But when we let go,
so you have to select
stop
the
jumping
thing to debug.
stops at the stop jumping. It doesn't make it to the next part. And that's when we notice we never actually hooked up our delay. Now if we were to test this, now we see the delay counting down, and we can see the execution for the rest of it. And we can see it says slow speed and full speed with 500 back to the normal, and we have our normal speeds. And if we were to test this, we slow walk, and then back to full. So that is watching execution. Now there's a couple things to know here. If you have multiple blueprints that are of the same type, you need to make sure you're watching the correct thing. We'll go back to our map, and we'll add a few more custom players in. Now only one of these blueprints I'm controlling. The rest just simply exist in the world.
I completely got distracted.
Speed with down, and we can see the execution for the rest of it. And we can see it says stop jumping stops at the stop jumping. It doesn't make it to the next part. And that's when we notice we never actually hooked up our delay. Now if we were to test this, now we see the delay counting down, and we can see the execution for the rest of it. And we can see it says slow speed and full speed with down,
delay
and we can see the execution for the rest. Now we see the delay counting down, and we can see the execution for the rest of it. And we can see it says slow speed and full speed with 500 back to the normal, and we have our normal speeds. And if we were to test this,
interesting,
we slow walk, and then back to full. So that is watching execution. Now there's a couple things to know here. If you have multiple blueprints that are of the same type, you need to make sure you're watching the correct thing. We'll go back to our map, and we'll add a few more custom players in. Now only one of these blueprints I'm controlling. The rest just simply exist in the world. If we go back to our custom player, we'll go ahead, hit play. We can see a brief, quick flash of our action executing, but we simply got lucky. If I go to my top, this is my filter view, and this will show you all the blueprints that you're currently in and all the active instances. We have 4 of them in here. What if by default it accidentally selected custom player 4, and then I went ahead and tested? Well, notice as I jump, nothing's actually happening. So that is important to know. If you're running into issues where you're not actually seeing execution, and you know you should, make sure the proper blueprint instance is selected under your debug filter. Now that we can see our execution, we have the ability to also modify that using breakpoints. Let me go ahead and put a breakpoint on my set right here. I can right click, toggle breakpoint, or add breakpoint. I can use the hotkey F9, and we can see we now have a break.
Okay. Sure, when we jump, why not? Toggle breakpoint.
Breakpoint set. The red indicator indicates an active breakpoint. Sometimes you may have a different color. You more than likely need to recompile and save your blueprint so your breakpoint becomes active. Now, when we hit play to test, I'll go ahead and hit jump, and you'll notice nothing happens again. Well, why is that? Again, we might not have the actual correct one selected. My actual player that I'm currently playing in the world is player 3. So if we go back to our blueprint and we change this to player 3 and go back to our active executing game, let's go ahead and jump again. And now you notice we immediately stop. So again, your filter is important. Make sure you're debugging the correct thing. Once the breakpoint's fired, it basically pauses execution. You can see execution firing up to this point. This is where we currently are, and this is where we're currently going. We have the ability to continue on from here. We could stop execution, for example, or continue. Now that we have this paused, we can go ahead and modify the execution by using the modifier hotkeys or by using the tooltips on the top. We have the ability to locate the currently active node. Perhaps we moved somewhere else. Clicking this button will focus on the currently paused node. We have the ability to step into the next node. Stepping in is when you have things like functions or macros, and you go inside of them. You can process everything inside of them, and then you come back out. Stepping to the next node means we go over anything that has something inside of it, like a function. So rather than going inside of it and coming back out, we just execute it all at once and continue to the next node. And then stepping out basically will stop where you currently are and step out and finish the macro or the function that you might currently be in. In this case,
yeah, it's all of that standard debugging tools. Dr. Elliot, heyo, how you doing? Hope you're gold, please. I has no gold. But, actually, I do have gold. I say I have gold. I forgot I had that.
we're going to step to the next node, and you'll notice execution now proceeds to the next node. Our set node has finished executing. Anything that needed to be done has been done, and we're now currently on our print string node. Note, you're currently on the node. It has not been executed yet. We haven't, for example, printed this string out to our log or our screen. Not until we continue playing or we step into the next node and there's no more nodes to fire will this node actually proceed. We'll step to the next node. Now we are back inside of our blueprint. We are running our game like normal. If we look at our controls, they've now changed. They're no longer in the breakpoint mode. Let's go ahead and get rid of our breakpoint. We can do this at real time. We can remove it or disable it temporarily. Now if we were to go back to our executing game and hit the spacebar, our nodes will fire off like we expected without actually
Standard
pausing.
debugging.
While we are paused, we have the ability to evaluate data. We can see the current value of things. If we mouse over any of these output pins,
Yeah, I want to see that.
we can see the result. The output of the get character movement node is this right here. It is a reference to the character movement. It's a class character movement component, and we can drill down and get more information about it if we want. Any of the properties. If we were to
Character movement. Oh. Whoa. That's pretty cool. Okay. Frame rate. Jeez. So, what absolutely just baffles me is because there's so much already built in to Unreal. It's like these characters already have so much built in. Just it feels like the amount of overhead would just be too much. Like grossly inefficient. But from my understanding, Unreal's pretty solid as an engine, so I don't know, whatever they're doing. Most expensive part is the CMC, that's why Pawn exists. CMC being this character movement controller component, character movement component, yeah. And then a pawn doesn't have that, right? Like that's one. I'm still learning a lot. But now Mover 2.0 is out? Ooh, what is this? What is that? Character Mover 2.0 experimental. But I think this might be dated. Mover plugin, character effort has the goal of massively improving existing character movement functionality. This might be a large endeavor, but has numerous touch points. Supports all actor types. Some game furniture focus on movement. Less complexities of networking. I'm guessing this has some pretty solid hooks into networking. Improves extensibility, modularity while empowering non-engineers to craft their own movement. Expand gameplay possibilities. Discarding rigid requirements. Improving interaction with physics stimulation. Supports generalized rollback networking. Interesting. Dr. Elliott, the CMC has a lot of functionality relating to networking, so it has a lot of overhead. Right, that's what I was thinking. Also, just the simple notion of it already having so much built in for networking that's pretty cool. It's like I've done some networking stuff in Unity with network objects, and I was like, you do quite a lot, and I was very impressed with what I saw. And what Unreal is doing is has blown me away, and I haven't even touched networking. That is like, I'm not getting into that yet. One step at a time. But yeah, there's some really cool stuff. But I didn't know that. I didn't even know that they were having this updated version of Character Mover. I hope that what I am running through tutorials on is not going to become too invalidated. Like learning something only to have to unlearn it immediately. The very basics are exposed to Blueprint, so it makes it very beginner friendly to get into multiplayer. C++ is where most of the magic happens for intermediate techniques. Yeah. I definitely will be looking into C++. I am intentionally working on learning blueprints, and because I want to really have a familiar understanding of how the blueprint system works, because it seems like it is used quite extensively. But I definitely am going to be dipping into C++ because I have C# and Java background and a couple other languages. But yeah, most of those YouTube tutorials are going to steer you wrong anyhow. I've heard that from a couple other viewers, yeah. So far, I am sticking to the official Unreal tutorials. Hopefully, they are not steering too terribly wrong. But yeah, I am explicitly looking at the actual official tutorials at the moment, and working my way through those. But yeah, I'd be very curious to find a tutorial on this character mover. I don't know enough about the character movement component to begin with to have a solid understanding of like what's the real differences and what's the improvements, because I don't know I don't know that yet. But it's always cool to have new tech like that. I'm curious to learn more about whatever it is. I pulled up something on the side to look into more later. New character movement channel. That was 4 months ago. So is it still in preview beta, or is it actually officially released yet? That I haven't found an answer to. Over 2.0 channel. Right now, SimC only gives you 4-bit flags for predicted movement. Yeah, I haven't dealt with predicted movement. Most of my multiplayer experience really didn't need predictive movement. I am very curious to learn it. I'm going to need to know it and how to use it and work with it for some of the stuff that I want to implement. But again, that is later. Because what I want to work on is going to need that. But yeah.
For
Let's see,
example,
where was
go ahead
I?
and step to the next one. If we mouse over to the output, we can see we have no debug data. We didn't do anything with this output. We set it to 300, but there's no output. We don't have a variable being saved. We have nothing in there that's valid. It is also important to note that none of this data is valid until it's executed. I'm going to add a new breakpoint down here on our set once we've landed, and I'll continue execution. We'll wait for it to...
Okay. Is this... Am I doing something wrong, or is this a bug? This flashing, like, I want to try and get into here, but man, it is not happy. Oh, wait, how I... Okay, maybe hovering over the actual node instead of the line. Oh, you can't see? Are you showing your screen or the engine? It should be what's on my screen at the moment. You should see the red exit line going. Wait, stream is frozen? Why is my stream frozen? Stream shouldn't be frozen. Let me pull up my stream. That's very much not supposed to be happening. Should not be frozen. Might need to refresh. Wait, hold on. Yeah, okay. Yeah, I just loaded in... Oh. Yeah, no, it's not frozen. Yeah, no, I'm aware how OBS treats that, and it's super annoying. Right at the moment, I am sharing my full screen. So it definitely should, and I just loaded the stream, so it might have to refresh. It might be a Twitch thing.
Trigger, and that's now paused on the set max walk speed of 500. It's pulling this value from our character movement. We can currently see that the value...
It was you refresh, now it's fine. Okay, so what I was showing, you see the red exit line, and when I hover over the actual wire, it flashes crazy, like you can barely get in there. But I can also just go straight to the actual start or end nodes, and it doesn't do that. I just was finding it challenging that the wire itself is not so happy. Hover over the actual pin. Yeah. I wasn't sure if that's effectively normal behavior. Like, okay, yeah, Unreal just does that. It's not just me. That's an Unreal thing. Hover over the pin. That was my question. Is this just me, or is this an Unreal thing? Can I align that to that? No. Oh, right, I can't. I'm in play mode. Quote unquote normal. Right. It's a feature. Noted. Thank you.
is 300, but our node is telling it to set it to 500. So why is it not 500? Again, we are stopped on this node before it has executed, so that value has not changed. When we step to the next node,
I'm aware.
we can now go back and look at our max walk speed, and you'll notice it's now changed to 500.
That I expect.
For our example, I've gone ahead and changed our code just a little bit. Now, instead of having a set walk speed that you will be slow for 2 seconds, we're going to get a random value. We use the random float and range node. It's going to give us between 200 and 500, and go ahead and set our max walk speed. While testing, something feels weird. We don't quite know what's going on. So we've gone ahead and added a print string to print out that value. Now, during testing, sometimes we get a low value, but our character walks really fast, or we get a high value and our character walks slow. Something isn't right, and we don't quite know why. Well, let's use the watch, let's use some breakpoints, and let's look at some values in real time and see if we can figure this out. We're going to put a breakpoint on our set max walk speed, because that's the first part where we're starting out our issue. And then let's go ahead and play. We'll go ahead and jump, and we trigger it. Now, if we look in here at a random float, we can see we have a random float value. This value is valid because this is a pure node. This node is ran every single time we ask for information. So we need the information to feed into this node. So when this node is executing, it's going to go backwards, get our character movement, and get our random float. So we have 284 as our value. So that's what we should be printing out. Let's go ahead and hit play to resume, but it printed out 444. Let's try that again. We'll go ahead and look at our values. Well, we got 219 this time. We'll hit play. It printed out 395. Something is wrong. So let's go ahead and test this out to see if we can figure out what's going on.
Jump. Stop jump.
Going wrong. We'll go ahead and break point. Let's go wrong. So let's see this time. We'll hit play. It printed out 395. Something is wrong. So let's go ahead and test this out to see if we can figure out what's going wrong. We'll go ahead and break point. Let's go ahead and look at our current max walk speed. It's 500, and we're getting a random value of 441. We'll step to the next node. Our max walk speed is 441 based on our random value. So we're good there. We'll go ahead and step to our next node. We'll look at our final print string here, and we'll look, and our random float's now 476. But we set it to 441 earlier. What's going on here? Before I mentioned that this node is a pure node, which means it's executed anytime we need information. It doesn't store the data. So even though there's one...
It's grabbing a random number for this and that.
One node here. Every time we ask for the information, when we're setting the max walk speed and then we're printing out the value, it's getting a new random value. So if you ever need something from a pure node to be used more than once, you probably want to save it or cache it. Set it as a new variable and then reuse that variable once the data has been set. One last thing I wanted to point out is while we are running this execution, we have our delay node. When it gets to that point...
So that makes total sense, and I didn't see it at first, but now that I know what to look for, it's like, oh, okay, no, that makes sense. I get it.
You notice it shows something at the top. It allows us to watch the value that's inside of our delay node. And we can actually do that with other values inside of our blueprint. Rather than having to pause execution and then mouse over the input or the output values, we can go ahead and add a watch to those values. You can right-click on any of your pins, input or output, and add a watch. For example, I will right-click on the return value from our random float and watch this value. Now you can see above it, it tells us...
Okay. What do I want to watch? I don't know if I really have anything that's... Uh, actually, you know what? Sure, why not? It just gives me something to watch. Ah, that's cool. Okay, that's useful. Stop watching.
It's watching the float, return value. And if we execute this program, anytime that value updates, our watch is going to update as well. So now we can see the value outputted is 264.77. And every time I jump, we're going to get a different value. And that watch is going to go and update. So this is really useful when you need to visually see values while your workflow is executing without having to stop it. So we've gone ahead and
That is
solved our
cool.
problem by using a combination of our print string, watching our execution flow, and then using our breakpoints. Stepping through our content as we need it is a great way to isolate what we need when we need it. There is another way to look at this data in a more general way, as well as have the ability to focus on specific things as needed, and that is using the Blueprint Debugger window. Let's jump right into the Blueprint Debugger window with an example so we can see how it can help us watch our program in real time and focus on identifying issues quickly. We can get to the Blueprint Debugger window by going to Tools, Debug, Blueprint Debugger. Now you may see data in our call stack if you've already been debugging. If not, we actually need a breakpoint so that way we can pause execution and then the call stack will work. I have this window over the gameplay window so that way we can actually see it in real time. We will go ahead and hit play to run our example, and I'll go ahead and interact pressing the spacebar. The call stack is immediately opened up, play window, so that way we can actually see it in real time. We will go ahead and hit play to run our example, and I'll go ahead and interact pressing the spacebar. The call stack is immediately opened up to where our execution was paused. If we look, we can see our...
Oh, because I have jump point. Not jump points, break points. Okay, so just for kicks, let's... no, go away. I don't want you. Let's go back to here. Oh, neat. I need to be able to see. You know, this really sucks trying to fit everything on one screen, even though I have multiple monitors. But I can't show the other monitors on the stream because the OBS. At least I don't know how to do that. Okay. I think that should be everything. Alright.
Our jump has a breakpoint. We can see we are in our event graph on the input action jump. The call stack can be read from bottom to top. So we have native code. Then we're inside of our blueprint with the input action jump. And then our event graph is currently where we are, right here in our jump function. I can show you a more detailed example. If I push another hotkey that I've set up, we can now see we have more information here. I have a custom actor that has an event for the O key. When the O key is pressed, it gets a hold of our character and tells our character to execute the custom event called something happened. So we can see here the O key, then the event graph, then we get to our custom player and we call something happened, and then
is this stack trace? This is effectively a stack trace, yeah?
Finally, we're in the event graph where we have paused our execution. So this is useful if you want to see once you've broken or a breakpoint has been triggered, what was the chain of events to get to that point. Next, we have our data flow. By default, the data flow has
call stack,
because there is no
right
flow
there
of data. Once we're running, we can see some data at the bottom start to fill up. Our execution trace. We aren't running any breakpoint right now, so nothing is really happening. We also aren't really watching anything, and that's the important part. We're showing the debug info for instances of this blueprint. None. We have nothing selected by default. Let's find our custom player, and now we're going to see some information start to show up. In our map, we have 4 custom players, so it's going to show us each of those 4 default. Let's find our custom player, and now we're going to see some
data flow. I don't know if that's what I need.
information is starting to show up. In our map, we have 4 custom players. So it's going to show us each of those 4 custom player blueprints or each of those instances. We can also see down here a list of breakpoints. These are the breakpoints that I have set up inside of this blueprint. We can also drill down into the data of these blueprints, into the properties while it's running at runtime. If we grab one of these, say custom player 3, it has a self, and all of the properties available to us are being shown. I can go back into the running project itself. Now, any variables that may update will update in real time. Let's go and drill down to something like our character's velocity. Right here, we have the character movement velocity variable. If we go back to our running example and move our character around, you can see our velocity now updates in real time. This is really useful to drill down and be able to find pieces of information at a glance simply in one window, our debugging window. And if we were to execute one of our breakpoints, you can now see our execution trace has paused with the jump action was fired. You can go right to it. We can see how long we've been executing for. And we can see a list of all breakpoints we have inside of our project. We have our normal controls up here as well. We can continue, we can stop, we can go ahead and jump through our breakpoints. One nice thing, let's say we are running our project and we've resumed and we want to watch them for, and we can see a list of all breakpoints we have inside of our project. We have our normal trace window. And if we were to execute one of our breakpoints, you can now see our execution trace has paused with the jump action was fired. You can go right to it. We can see how long we've been executing for. And we can see a list of all breakpoints we have inside of our project. We have our normal controls up here as well. We can continue, we can stop, we can go ahead and jump through our breakpoints. One nice thing, let's say we are running our project and we've resumed and we want to watch some values, but some of our breakpoints are getting in the way. We can disable all breakpoints. You'll notice they now become disabled. They are hollow. And if we go back to we can disable all breakpoints. You'll notice they now become disabled, but some of our breakpoints are getting in the way. We can disable all breakpoints.
Oh, it's in the top right there. Got it.
You'll notice they now become disabled. They are hollow. And if we go back to our execution of our project and I run around and jump, our values are updating, but I'm no longer triggering any of our breakpoints. This is a really useful window, especially if you have multiple monitors or a way to always watch this data. So you don't have to jump back and forth between different blueprints to see what's going on. You can look at them at a glance in one organized window.
Yeah, that's cool. I saw the changes there.
To display data that exists in our programs, as well as to try and follow the execution of the program while it runs. We also have a few ways to add additional data in the form of debug shapes that will help us. Sometimes you need to see more when working with your project when you run into a problem. Up to this point, we've used existing data to try and debug a potential problem, but the editor gives us another way to visualize that data while the project is running in the form of debug shape. There are many debug shapes. We're just going to take a look at a few of them to give you an idea of what you may use them for and how they work. If you'd like, you can go to Window, Palette, and you can search for Draw Debug, and you can get a list of all of the debug shapes that we have available to us, from things like an arrow, a cylinder, a line, to shapes that you may use them for and how they work. If you'd like, you can go to Window, Palette.
Oh, there it is. Let's go to that for now.
And you can search for Draw Debug, and you can get a list of all of the debug shapes that we have available to us, from things like an arrow, a cylinder, a line, to more complex things like a coordinate system and float history. We're going to take a look at the capsule, the string, and the arrow just as 3 quick examples. I'm going to drag out the Draw Debug capsule. All of your debug will have the same basic pieces of information. Where do you want it, and what do you want it to draw? It also has a few custom options for the visual ones, such as maybe the color and the thickness of any lines. For this example, when we play, someone's gone in and done some changes, but now all of a sudden our character is, well, floating in midair, and we don't know why. We have a capsule component as our primary item. Now, we do have the ability to view this collision data inside of the editor, but we can also use our debug shapes to visualize these things. I'm going to hook up my Draw Debug capsule to my begin play. My center is going to be the actor's location. My half height and my radius are going to be whatever I've set my capsule half height and radius to. So I'll get the capsule component, and I'll get those 2 properties. I'm going to want to keep the rotation by default. I'm going to change the line color to something a little more visible, maybe a red. We're going to make our duration something longer, say around 10 seconds, and our thickness to around 3, just so we can easily see this. We'll go ahead and hit play to test, and now we can see our problem. Our capsule on our character is much taller than it should be. If we go back to our details panel for our capsule, and we look at what our coworker did, we realize they made the mistake, and they set the capsule height instead of the capsule half height. We change it back, and we test, and we see that everything is now back to normal. For the next example, our level designers want some more information about the level around them while they are designing. So we've added a line trace. This simply fires out a line trace 1,000 units ahead of us, and it's useful because we can see the items it hits. Our designers want some information about parts of our level, such as where they are. We can easily use the debug string in order to figure out where we are hitting and display that information in real time. Let's go ahead and hook up a Draw Debug string, and then it wants some information similar to the capsule, such as where this text is going to be located, what text we're going to see, and then things like the color and duration. Since we're going to do this on our tick, we're going to leave our duration at 0. We'll leave the color at white. Our text is going to be the location where we are going to hit, which is also the location where we're going to put the text. We'll break apart our out hit, with a split. Out hit location goes into the text location. Out hit location goes into the text. It'll convert automatically. And let's test this. We can visually see represented in the world that exact location. The nice thing is you could also adjust it with things like maybe different colors depending on what you're hitting. You can have things like maybe the material you're hitting. So you can have a visual debug mode in the editor by adding strings as needed. This also has the advantage over print string, where the debug string can be anywhere in the world itself, not just in the top left corner. And the last shape I want to look at is the arrow. So let's try draw debug arrow. The debug arrow, very similar. We have a line start, a line end, arrow size, color, duration, and thickness. Since we're doing this on tick, we're going to keep the duration to 0. We'll make the thickness 3 so we can easily see this. We'll make our arrow size somewhere around 30. For our line start, we're going to go ahead and use the hit location. For the line end, we're going to do something very similar to what we did for the actual line trace. We're going to get the normal, figure out how far we want it to go out, and use that for the line end. I'm also going to change our line color to something a little more visible, say a green. And let's test this out. When you go up against something, you'll notice I now have a green arrow pointing out in the direction of the normal of the surface that I've hit.
Yeah.
That was just a few of the examples of the debug shapes. As you saw earlier,
That's
there are
cool.
plenty more to experiment with and use. Once our projects get large and our processes start taking more time to run, we need a way to try and isolate parts of the code we may not want to run while debugging. And we can do that by enabling and disabling nodes in the editor.
Yes, that I definitely want to know how to do. I'm sure this is
When
going to be
working in the
pretty
editor,
straightforward.
you might have noticed some text under some of the nodes that say development only. Our print string node is one of them. This is a special flag on the node that tells the editor when we finalize our project to not run these nodes, and it's a great way to use only parts of our code when we are testing or debugging. In addition, we have the ability to flag a node as disabled, which is a great way to isolate the code that is being executed to focus only on the parts we want when testing. Now, by default, this is disabled, and there are no hotkeys set up for it. So let's look at how to take care of that. These are editor keyboard shortcuts. So let's open up the editor preferences, edit, editor preferences, and we're looking for keyboard shortcuts. Now we're looking for disable nodes, enable nodes, and development only. Now we can search for those, or we can go directly to the section. I've gone ahead and done a search for disable nodes to show you this is under general, keyboard shortcuts in the graph editor section. You'll notice there is no binding. You can set this to whatever you want. I'm going to go ahead and set a few shortcuts for these. We also have enable nodes. We have 3 options for enable nodes. We have enable nodes always, and enable nodes development only. With the introduction of development only enabling, we have the ability to always or development only nodes, so the enable nodes hotkey itself is non-functional. You'll want to set up always and development only. With those shortcuts set up, let's go ahead and look at how we can use them.
Interesting. So there's no way to do that in the actual editor? Interesting. Where was that thing that had a huge chain of stuff? Oh, I think it was here. It's also this, but this will probably work. Yeah, interesting. Okay, I don't know what good binding there would be, because I don't know other keyboard shortcuts. Let's just see what happens if I do this. Nothing. Sure. Enable nodes.
We have the ability to always or development only nodes, so the enable nodes hotkey itself is non-functional. You'll want to set up always and development only. With those shortcuts set up, let's go ahead and look at how we can use them. Inside of my custom example here, I have a very simple setup, like we've seen before. When the character jumps, it's going to slow them down, and then for 5 seconds afterwards, they will walk slower. And if we test it, we can verify it works as like we've seen before. When the character...
Okay.
With those shortcuts set up, let's go ahead and look at how we can use them. Inside of my custom example here, I have a very simple setup, like we've seen before. When the character jumps, it's going to slow them down, and then for 5 seconds afterwards, they will walk slower. And if we test it, we can verify it works as expected. Now, we've gotten some feedback that this is annoying, and someone would like to test it without the slowdown. Now, without the ability to enable and disable nodes, you would have to disconnect the nodes that you do not want, and then reconnect the wires. With the ability to enable and disable nodes, we can temporarily or permanently disable them as needed. So I'm going to use the hotkey for disabling, and you'll notice the wires coming in, as well as the node itself, has become a darker gray. These nodes are now disabled and will not fire.
Okay. I don't know why you didn't take. Development only. Oh, there we go. Oh. Interesting, okay.
And if we test, our character no longer slows down. We can, of course, verify this with execution watching. When I jump, you'll notice it stops and it does not continue on. Now, one thing I want to show you was even though you didn't see the execute wire going to the awesome jump event, it was still enabled. I've added a print string at the end after the awesome jump effect, and we still have the set node disabled. And when I jump, you can see it does execute and our text shows up in the top left.
Yeah, that makes sense.
So when you enable or disable nodes, it only affects these selected items. Now I can go ahead and re-enable these by using my hotkey, and you'll notice our wires come back on and the nodes are now enabled again. Now, for development, this generally only works on functions or things we can execute, not really setters and getters. I will go ahead and select my set max walk speed and use the hotkey for development mode, and you'll notice nothing really happened. We can do the same thing with some of our getters down here for our peers, and you'll notice nothing is happening. But if we do it on our custom events, like let's say our awesome jump event, you'll notice they now say development only. You can also toggle between development only and normal by setting it back to enable nodes always, and it will even work on something like this print string node. So this gives you the ability to alter the flow without disconnecting or reconnecting a bunch of wires,
Okay, that's
and the
cool.
ability to have things in development mode, which is very similar to the way the print string works. Now, there is one other way rather than the hotkey, but it is an experimental option. We'll go back to our editor preferences, go to our blueprint editor settings, experimental, advanced. You have the option here, allow explicit impure node disabling.
Experimental. Where did they go? Experimental. Here. Allow explicit impure. Yeah. Allow explicit node disabling. Allow explicit node okay. Turn on.
And we'll enable it. We can go right back into our blueprints, and if we right click, now you'll notice we have the options down here for disable, do not compile, or enable always and development.
Oh, there we go.
The hotkeys that we've set up. So we can go ahead and set these back to where they were
Sweet.
before.
Okay, that's more what I would like to see. Disable, do not compile, and enable. Okay, good. Got it.
Using the right-click option, so enable always. And that's how you have the option to have right-click toggling rather than just the shortcut. This was a fundamental look at the concept of debugging in blueprints and some of the tools that the Unreal Engine editor gives us when working with the editor. When things go weird in the future, you should now have a good start on identifying what is going wrong and how to find ways to fix the issues.
Okay, cool.
The concept of debugging as a whole can apply to any work you're doing inside of the engine as well. With the methods we covered in this course, you'll have an idea of what you can do to validate your data as you use it, as well as identify your possible issues you might encounter. We started by looking at the ability to print string, or put the data in an easily accessible place on your screen and in your log. This is useful when we need to validate or check or verify something is actually what it's supposed to be. Then we looked at breakpoint debugging. This is a standard feature of most development systems, using the breakpoint to pause execution of code, see what the current values are of everything that you're working with, and then walk through your code line by line or node by node. We use the Blueprint Debugger window to have an easy view into what is going on in our project at the current moment, as well as the ability to look at the data flow for individual blueprints in a nice organized window. Debug shapes can be used to visualize that data in, well, a visual format. We have a variety of different debug shapes and types and values that we can use to easily see that data, and then maybe that would let us know what is going wrong. When working with a larger blueprint, and you may need to reroute things that are going on or temporarily not do something, rather than rewiring your code up, you have the ability to mark nodes as enabled or disabled, as well as flag them for development only, so that way you can easily change the flow in your editor without having to rewire everything. This was just a quick look at some top-level methods of blueprint debugging. There are much more advanced methods, so look out for other courses on those methods, as well as the official Unreal Engine documentation on the Unreal Engine website. Remember, when you're working on a project, problems can and will happen. It is a normal part of the process. By using these methods to track down those issues, you can get a clear picture.
All right. I'm going to go ahead and call it here, I'm afraid. Thanks everyone for hanging out. As always, be well, be safe, be yourself, be kind, be all the good things. Have a great rest of your day.